Recording in progress.
Good morning, Mr. Wahyudiasti from ICEEIE Indonesia section.
Good morning, Pak. Selamat pagi.
Terima kasih, Pak.
Hai teman-teman, yuk jalan-jalan ke jurusan Teknik Elektro Universitas Negeri Malang. Teknik Elektro adalah bagian yang tidak terpisahkan dari Universitas Negeri Malang sejak tahun 1981. Jurusan Teknik Elektro memiliki 7 program studi, mulai dari prodi pertama yang dibentuk pada tahun 1997, yakni D3 Teknik Elektro. Kemudian disusul oleh prodi D3 Elektronika pada tahun 1998. Pada tahun 2007, lahirlah S1 Pendidikan Teknik Informatika. Di tahun 2009, muncul prodi S1 Pendidikan Teknik Elektro. Masih ada lagi dong, pada tahun 2014 berdirilah S1 Teknik Elektro dan S1 Teknik Informatika. Dan yang paling baru di tahun 2017 adalah S2 Magister Teknik Elektro.
Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Novi Trisman Hadi. Saya alumni jurusan Teknik Elektro angkatan 2011. Saya lulus tahun 2015. Saat ini saya bekerja di SMK Negeri 3 Batu dan juga SMK Brawijaya Batu sebagai pendidik, dan juga saat ini saya sedang merintis perusahaan startup di bidang IT. Saat ini saya masih menjalin kerjasama dengan jurusan Teknik Elektro dalam bidang akademik, yaitu berupa pengiriman siswa kami untuk kegiatan praktek industri. Harapannya siswa kami nanti bisa mendapat ilmu dan juga pengalaman seperti yang saya dapatkan pada saat kuliah dulu. Semoga tetap jaya selalu Teknik Elektro. Salam Unity.
Jurusan Teknik Elektro atau TEUM berpusat di 3 gedung sebagai fasilitas pengelolaan, pendidikan, penelitian, pengabdian, dan kegiatan mahasiswa. Dengan semangat yang kuat, mewujudkan jurusan Teknik Elektro sebagai jurusan yang unggul dan menjadi rujukan nasional dalam pengembangan bidang pendidikan dan sains, khususnya dalam bidang pendidikan Teknik Elektro dan Informatika, yang relevan dengan kebutuhan pembangunan, masyarakat, dan kemanusiaan. Mahasiswa Teknik Elektro saat ini berjumlah lebih dari 3.606. Mereka sering memenangkan berbagai kompetisi nasional maupun internasional, serta memiliki berbagai sertifikat kompetensi lainnya. Saat ini, jurusan Teknik Elektro mengelola 4 jurnal, diantaranya adalah Knowledge Engineering and Data Science, Letters in Information Technology Education atau LITE, Tekno, Jurnal Teknologi Elektro dan Kejuruan, serta Frontier Energy System and Power Engineering, dan juga bekerja sama dengan berbagai instansi dalam negeri maupun luar negeri. Jurusan Teknik Elektro UM juga telah menghasilkan lebih dari 1.245 penelitian, 576 publikasi, 74 HKI dan pengabdian kepada masyarakat sebagai bukti nyata berkelanjutan dalam menjadikan jurusan Teknik Elektro yang unggul dan berprestasi dalam sains dan teknologi. Jurusan Teknik Elektro digerakkan oleh 3 profesor, 18 doktor, 34 calon doktor, 11 dosen berkualifikasi magister, dan 11 tendi dan laboran berkompetensi tinggi, menjadikan institusi yang dinamis, bergerak cepat seiring kemajuan sains dan teknologi, serta berkolaborasi dalam skala nasional maupun internasional. Inspirasi daya dan data adalah pola pikir yang tercermin pada program studi dalam berkontribusi di bidang pendidikan, penelitian, pengabdian di era teknologi yang semakin maju. Berbekal kompetensi dan semangat yang tinggi, serta kerjasama yang erat, menjadikan jurusan Teknik Elektro Unity.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Live from Malang, Indonesia, welcome to the International Conference on Electrical, Electronics, and Information Engineering 2021.
Ladies and gentlemen, before we officially begin our conference, we will rise and sing our national anthem of Indonesia Raya.
Assalamualaikum warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen.
The Honorable, the Chairman of ICEEIE 2021, Ilham Ari El-Bazaini, PhD.
The representative of IEEE Indonesia, Doctor of Engineering Wahyudi Hasbi.
The Rector of Universitas Negeri Malang, Profesor Dr. Aha Rofi Udin.
The Dean of Faculty of Engineering Universitas Negeri Malang, Profesor Dr. Marji Mkes.
The keynote speaker of ICEEIE 2021, Profesor Dr. Taufik from California Polytechnic State University, USA.
Professor Chen Sejong, PhD from Southern Taiwan University of Science and Technology, Taiwan.
Doctor of Engineering, Anik Nurhandayani from Universitas Negeri Malang, Indonesia.
Professor Martin Ebner, PhD from Graz University of Technology, Austria.
It is my pleasure to stand up here to lead our today's conference on the 7th International Conference on Electrical, Electronics, and Information Engineering 2021 with the theme Technological Breakthrough for Greater New Life. I am Rofi Anggara.
And I am Grace Angeline.
Appreciate you all for think and busy to join us today on Saturday, 2nd October 2021, live on YouTube.
Thus, we would like to thank the Engineering Faculty of Universitas Negeri Malang for organizing and hosting this event. We hope we all learned a lot from today's conference, which I believe is fruitful and engaging.
As the international event of the Electrical Engineering Department, Universitas Negeri Malang, ICEEIE 2021, is presented to serve as a platform for international exchange of ideas, collaboration, and cooperation.
The main objective of ICEEIE 2021 is to provide a scientific forum for scholars, lecturers, researchers, and practitioners to exchange their ideas and innovations on the latest trends or novel results in the field of electrical, electronics, and information engineering for bridging future technologies.
Various preventive actions have been taken and localized by the government to prevent the spread of the virus. So we change the presentation from oral to a remote presentation through video conference.
To symbolically open today's conference, we would like to invite the chairman of ICEEIE 2021 to do the welcoming speech. Please welcome Ilham Ari El-Bazaini, PhD.
Assalamualaikum warahmatullahi wabarakatuh. The Honorable Rector of Universitas Negeri Malang, the Honorable Dean of Engineering Faculty Universitas Negeri Malang, the Honorable Board Leader of Universitas Negeri Malang, the Honorable Chairman of IEEE Indonesia Section, the Honorable Keynote Speaker of ICEEIE 2021, the Honorable Author, Participant, and Organizer of ICEEIE 2021. On behalf of the Steering Committee, Technical Committee, and Organizing Committee, it is my great pleasure to welcome you to the 7th International Conference on Electrical, Electronic, and Information Engineering, ICEEIE 2021. The ICEEIE 2021 is an international scientific forum that held by Electrical Engineering Department, Universitas Negeri Malang. The ICEEIE 2021 is held in collaboration with IEEE Indonesia Section as technical co-sponsor. The ICEEIE 2021 is a conference held every 2 years to bring together researchers, engineers, practitioners, lecturers, and students from across the world. This conference is intended to be a bridge for sharing the most recent and cutting-edge discoveries and inventions from around the globe in the context of technological breakthrough for greater new life. The keynote speaker of ICEEIE 2021 come from Austria, United States of America, Taiwan, and Indonesia. There are 604 authors from 24 different countries across 5 continents who have contributed to the ICEEIE 2021 through various titles of papers. The author of ICEEIE 2021 come from Indonesia, Japan, Malaysia, Taiwan, Turkey, Cambodia, Morocco, India, Philippines, Bangladesh, USA, Iraq, China, Australia, Poland, Iran, Belgium, Mauritius, South Africa, Sudan, South Korea, Pakistan, and Colombia. There are 175 papers submitted to the ICEEIE 2021. However, only 122 high-qualified papers have been accepted for the oral presentation based on the review result and recommendation. I would like to express my appreciation to all participants and contributors, and also I express my gratitude to each dedicated member of the steering committee, technical committee, and organizing committee, and also all the volunteers. Finally, thank you for the great effort and well done. Wassalamualaikum warahmatullahi wabarakatuh.
We would like to invite the representative of IEEE Indonesia to do the welcoming speech. Please welcome Doctor of Engineering Wahyudi Hasbi.
Distinguished guests, colleagues, researcher, professional, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good morning, a prosperous and warm greetings. First of all, please allow me to greet the Honorable Rector of the State University of Malang, Professor Dr. Aha Rafiuddin, and all Vice Rectors, Dean of Faculty of Engineering, the State University of Malang, Professor Dr. Marji M. Kes, General Chair, the 7th International Conference on Electrical, Electronics, and Information Engineering, or ICEEIE 2021, Ilham Zaini, PhD, all distinguished keynote speakers from various institutions and countries, all the committees, all participants, ladies and gentlemen. It's such an honor and pleasure for me to be able to greet you all and give you a few words to represent the IEEE Indonesia section at the opening of this conference. On behalf of IEEE Indonesia section, I would like to express my sincere gratitude and welcome you to the 7th International Conference on Electrical, Electronics, and Information Engineering 2021, which is organized by Electrical Engineering Department, University of Malang. Distinguished guests, colleague, researcher, professional, ladies and gentlemen, as the international event of Electrical Engineering Department, University Negeri Malang, the ICEEIE 2021 is presented to serve as a platform for international exchange of ideas, collaboration, and cooperations. The main objective of this conference is to provide a scientific forum for scholar, lecturer, researcher, practitioner to exchange their ideas and innovation on the latest trends or novel results in the field of electrical, electronics, and information engineering for bridging future technology. Distinguished guests, colleague, researcher, professional, ladies and gentlemen. As we all aware, the impact of COVID-19 is felt in every aspect, and there has been a shift in the standard of living. It has strengthened the drive and encouraged intensified collaboration between governments, companies, and non-profit organizations. And it's also highlighted the required for communities to drag together and handle the risk. In just a few months' time, the COVID-19 crisis has brought about years of change in the way companies in all sectors and regions to do business. Broadband, wireless communication, 5G, Zoom, and other platforms, all of these technology have been elevated by this pandemic, including high demands of electricity in every houses due to the pandemic. Other services like artificial intelligence enable remote patient monitoring and diagnosis can be supported by wireless network to allow anyone with a medical condition to report back to their local or central healthcare system without having to physically present. This is especially important for people living in more remote area. And due to travel restrictions caused by COVID-19 outbreak, it may be difficult to or impossible for many patients and surgeons to attend more equipped hospital, typically located in a larger city. Another use such as wireless communication system is very effective in tracing of potential COVID-19 contacts, whereabout by employing cellular network type of localization technique and offer disease management via integrated personal mobile apps. As in Indonesia, we call it as a Peduli Lindungi application. In such so, I believe that the theme of this conference, Technology Breakthrough for Greater New Life, is very relevant to these rapid changes and very important in highlighting the innovation to accelerate the shift to digital and the fundamentally shake up the living landscape. Distinguished guests, keynote speakers, ladies and gentlemen, IEEE Indonesia as a regional organizational unit of IEEE was founded in 1988, and over the past 33 years, IEEE Indonesia has contributed significantly to various activities that encourage science and technology for humanity in Indonesia. Together with all the volunteers, members, and all stakeholders, IEEE Indonesia has produced various activities by supporting more than 20,000 IEEE conference publication and more than 260 IEEE journal publication by only Indonesian authors since 1988. However, we need to encourage the increase of number of publication should be accompanied by increase of citation, which is very important right now for a world-class university by conducting research, collaboration, and internalization higher education activities. IEEE Indonesia also sponsored and supported more than 60 high-quality conference every year, including this conference, which is, I believe, is very great conference. And compared with the previous year in 2021, we have an increase about IEEE Indonesia conference for about 49%. So as we all know, the high qualified conference papers within the scope of IEEE are published in the IEEE Explore Digital Library, which is indexed by Scopus Web of Science and other major databases with more than 5 million publication and more than 12 million downloads every month. As we all know, IEEE always maintain high-quality publication as part of our intellectual culture. IEEE Indonesia also holds more than 40 professional, technical, non-technical, administrative activities every year for all its members. And currently, we have more than 2,400 members and more than 60 senior members consisting of professional, industry, academia, and government research members. IEEE Indonesia also supported more than 26 technical society chapters and joint chapters, and also including 30 university student branches over the Indonesia. On July 27, 2021, IEEE Indonesia has established cooperation agreement with Directorate General of Higher Education, Research and Technology to synchronize and support IEEE activities in the Indonesian Ministry of Education and Culture, Research and Technology Program, including taking part in the Campus Merdeka, Merdeka Belajar, or Independent Campus Freedom to Learn. This historical collaboration shall strengthen the development of Indonesian higher education, especially the 8 leading indicators of higher education in Indonesia. Ladies and gentlemen, on this occasion, I would like to express my gratitude to all the committee of the conference who have worked very hard in preparing for this high qualified IEEE conference. I am aware that putting together a conference of the size of numbers of papers, you mentioned 175 submission, is not an easy task to be handled. Therefore, I sincerely hope your cooperation and active participation in all of this program. So I hope all of you will have enjoyable and valuable experience during this conference event. So please stay active, stay healthy. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Hasbi.
We would also like to invite the Dean of Faculty of Engineering Universitas Negeri Malang, continued by the Rector of Universitas Negeri Malang, to do the welcoming speech. Please welcome Professor Dr. Marji Mkes and Professor Dr. Aha Rofiuddin.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. I am honored to welcome you to Universitas Negeri Malang this year to attend the 7th ICEEIE 2021 organized by the Faculty of Engineering. I hope we enjoy the event. Good luck and have a great conference. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi and good morning. The Honorable Dean of Faculty of Engineering, the Honorable all of speakers, and all of participants in this conference. First of all, please allow me to attend a warm greeting to all of you attending the virtual meeting of Universitas Negeri Malang. Our university is located in Malang, a lovely area with an intellectual atmosphere comprised of a chevron learning institution and nature resort. I'm glad to welcome you to the 7th International Conference on Electrical, Electronic, and Information Engineering 2021 as one of our international forum for sharing practice and current innovation and invention across the world. I welcome all of the keynote speakers here. First, Professor Martin Ebner, PhD, from Pest University of Technology, Austria. Professor Dr. Taufik from California Polytechnic State University, USA. Professor John C. Chung, PhD, from Southern Taiwan University of Science and Technology, Thailand, and Dr. Engineering Ani Nur Handayani from Universitas Negeri Malang, Indonesia. It is also a great pleasure and honor for us to host this conference, which is being organized by the Department of Electrical Engineering. I hope that the conference will strengthen and expand Universitas Negeri Malang's commitment to international partnership and collaboration. Furthermore, as our motto, the Learning University, such as I hope it will be fascinating learning experience for every one of you. The ICEEIE 2021 will provide a forum for academics, scientists, researchers, and practitioners to exchange ideas and explore new technology and application of their finding. It is also intended to tackle some challenges, including environmental awareness of energy sustainability, green and applied technology in several phases of human existence, and life-based learning for long-term education in electrical, electronic, and information engineering. Finally, I would like to thank and congratulate to steering committee, technical committee, organizing committee, operational section, and student volunteer for their outstanding work. I hope that the ICEEIE 2021 will be a success for future international relationship and collaboration among all others and attendants of this conference. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Dr. Marji Mkes and Professor Dr. Aha Rofiuddin.
As we are now officially open to commence today's conference, to cherish you all this morning in celebrating this event, we present you the 7th International Conference on Electrical, Electronics and Information Engineering 2021.
As the conference is officially open, before we begin the conference, I would like to call Mr. Rudi Rahayu to lead our prayer.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, let us pray for the success of the International Conference on Electrical, Electronics and Information Engineering 2021. With them, technological breakthrough for greater new life held by the Electronic Engineering Department, Faculty of Engineering, State University of Malang. Before we officially open the event, allow me to lead dua in Islamic way. Attendees may pray according to their own religions and belief. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Hamdan syakirin, hamdan na'imin. Hamdan yu'afi ni'amahu wa yukafi majidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karim wa 'azimi sultanik. Allahumma inna nas'aluka salamatan fid din wa afiatan fil jasad, wa ziyadatan fil ilmi, wa barakatan fi rezeki, wa taubatan qoblal maut, wa rahmatan indal maut, wa maghfiratan ba'dal maut. Allahumma hawin alaina fi syaharatil maut, wa najata minan nar, wal afa indal hisab. Rabbana la tuzigh qulubana ba'da idh hadaitana wa hab lana min ladunka rahmah innaka antal wahhab. Rabbana ighfir lana wa li walidina wa li jamil muslimina wal muslimat wal mu'minina wal mu'minat al ahya'i minhum wal amwat innaka ala kulli syai'in qadir. Rabbana hab lana min azwajina wa dzurriyyatina qurrata a'yun waj'alna lil muttaqina imama. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar wa adkhilal jannata ma'al abrar ya aziz ya ghafar ya rabbal alamin. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Now, we are going to do a photo session, so we would like for all the participants to the open camera and give your best pose.
Participants from Asia, please raise your hand to the camera. Thank you.
Next, participant from America, please say hello to the camera. Hello. Thank you.
Participants from Europe, please show your best pose to the camera. Thank you.
Next, participant from Australia, please smile to the camera. Smile. Thank you.
Participants from Africa, please raise your hand to the camera. Thank you.
Before we hand over this forum to the moderator, I am Rofi Anggara.
And I am Grace Angeline, as your Master of Ceremony, deliver our greatest thanks to all the speakers, moderators, committees, and participants.
Without further ado, I would like to invite the moderator. Please welcome Haris Ar-Rasyid, PSD.
Thank you. First and foremost, I would like to welcome you, ladies and gentlemen, to the International Conference on Electrical, Electronics, and Information Engineering 2021. Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. In this occasion, we will have presentation from 4 keynote speakers, 3 talks before the parallel session, while Professor Martin will present after it. Allow me to introduce myself. My name is Haris Ar-Rasyid. I will be hosting you throughout the talks from our keynote speakers. So, let's begin with our first keynote speaker. He is Professor Dr. Taufik, a professor in electrical engineering, California Poly State University, California, USA. He has a vast experience in academic and industry and received a number of recognitions and awards. He also holds patents, wins glorious grants, as well as numerous publications. His research interests are power electronics, power systems, energy harvesting, smart grid, renewable energy, and power quality. So, without further ado, please welcome Professor Taufik. The stage is yours. All right.
Auzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Let's see. Can you hear me?
Yes, Professor. Loud and clear.
All right. Okay. Yeah, thank you for having me to this conference. It's a great honor to be here. It's always, a pleasure to be given the opportunity to share my research interests as well as experience, with my colleagues around the globe. So again, thank you. And for today's talk, I will briefly go over my research that I have started since 2010. Has been my main passion, since then, and that relates to DC electricity. And by the way, how much time do I have for the presentation?
Around 30 to 35, Professor.
Okay, inshallah. So I'll go ahead and start by sharing the screen, if you don't mind. Let's see. Okay, presentation. Hopefully you can see my PowerPoint presentation, yes?
Yes.
All right. Okay, so the title of my presentation today is going to be DC House as the Future Technology and Residential Electrification. I think the scheme of this conference is around advancing technology, right? Science and technology. And one of the things that I have attempted to partake in this effort is by looking into the DC electricity as a way to advance electrical systems, especially in rural areas. People who have not had the opportunity or the chance to enjoy or to utilize electricity. Right? So that's the main reason behind this research. And my name again is Taufik. I'm currently a faculty member in the electrical engineering department at Cal Poly State University in California, USA. Just briefly, the school itself is located in California, state of California, in between Los Angeles and San Francisco. So it's on the western coast of the U.S. And we are in between the two industrial areas, close to Silicon Valley. And yeah, hopefully a beautiful place. Hopefully someday, one of you could have the chance to visit our campus. You're always welcome to do so. Hopefully after the pandemic is over. But then again, going back to my presentation, these are the outline of my presentation today. Why DC? What is the DC House project? Components of the DC House, recent status of, and then I'll go over some examples on how to apply the technology using implementing it in off-grid electrical systems as well as future houses. And then I'll close the presentation with a summary. All right, let's talk about why DC in the first place, right? I mentioned earlier that I looked into how to use DC electricity to advance, to make progress or advancement in electrical system technology. And so one of the reasons why DC to me is going to play a very important role in the future of electrical systems. This is one example of it, or one reason, I should say. Using three examples. Very first reason is that I've observed that there are increasing numbers and uses of residential DC loads. If we were to meet in person right now, if I were to stand in front of you in person, I would ask the audience, Raise your hand if you have cell phones 15 years ago. I would imagine, only a few, maybe none, raise their hand. But then if I ask, how many of you have cell phones today, right now? I would say maybe every one of you will raise the hand, right? And maybe um, quite many of you will have more than one cell phone, right? Now, why is that important? Well, because cell phones internally is running on DC electricity, not AC, right? It's powered off by a battery, right? And yes, when we charge the cell phone, we have to plug it on the wall, right? And therefore it's AC, but internally is actually DC. So what we're doing is that we convert the energy from AC to DC, right? And more important than that, as you can see from this figure right here on the left, you can see the increasing number of cell phones around the globe, right? By 2021, was projected that about 2 billion cell phones would exist around the globe. And that's not a small number, that's a significant number, right? And how is that relevant to the DC electricity? Well, as I said earlier, a cell phone is running off DC, right? And if around the globe there's only one cell phone, then that's not a big deal, right? DC is not a big deal. But the thing is, we have around 2 billion. So when we look at global scale, you can see that the energy being used by 2 billion cell phones through DC electricity becomes humongous, right? You can see 5 volt is typically how we charge the cell phone, right? Typically with USB. And then let's just say that 1 amp is how much current going through the cell phone as we are charging. And this is kind of a low number, 1 hour. Let's just say that when we're charging the cell phone is for 1 hour. And you can do the math in your head, right? 5 times 1 times 1, right? That's only 5 watt hour per phone. Right? But that number is small, of course. But then if you multiply that by 2 billions, then that number becomes so big, right? Look at the zeros there, right? In fact, that number is around 10 gigawatt hour. Right? That's not a trivial number anymore. And this is only from a cell phone. We have other portable devices, not just cell phones, right? Such as tablets, for example. And here's the same thing with tablets. And tablets, just like cell phones, internally is running off DC. And then another technology that has become very popular in the past decade is the LED lights, right? Again, if I ask you 10 years ago, did you have any LED light bulbs in your house? The answer is probably no, right? But nowadays, this is very common. You can see the number is increasing exponentially. Same thing in the US. 10 years ago, very rarely we see light bulbs being sold, but nowadays majority of the light bulbs being sold are LEDs, right? It would be a remiss if you're not using LEDs, because then you're not really saving energy by not using LED light bulbs. So point is, all of these 3 examples hopefully emphasize the significance increase in DC load in our house, right? Just the 3. Now we know we'll have more, right? We have more of DC loads such as laptops, TVs, right? And so on and so forth. Another reason why I believe DC will become very important, DC electricity, especially for residential scale electricity, is the introduction of USB-C, which again has become more popular these days, right? USB-C, they look like this. I'm sure most of you are familiar with USB-C, and this USB-C technology has so many features. But as a person who has a background in power, I am most interested in one of the features that relates to power, and that would be this feature right here, right? That this USB-C technology, the target output power, imagine this, okay? The target output power is 100 watts. Now picture this, right? 100 watts. If you can get 100 watts from a USB plug like this, then imagine how many DC loads you can actually power through a USB-C. A lot, right? A laptop, for example, typical laptops, right, consume about or require about 50 to 60 watts. So easily, right, in the future, you could just use USB-C to charge laptop rather than going to AC first, right? TV, same way, right? And a small fridge, for example, if it's DC fridge, you can also power through USB-C. Anyhow, this is a very exciting, technology, and although the power is not quite there yet, I think right now, based on what my friends told me in Silicon Valley, right now the wattage goes up to about 25 watts, so still a long ways to go to 100 watts. But it's going there, right? It's still progressing, and that's what's exciting about this opportunity, this technology. And I ran some statistics some time ago between 2000 and 2018. The percent mix, right, of loads between 2000 and 2018 in typical residential house in the US. You can see that in 2000, DC loads comprises about 20% of the entire load, electrical load in a house, typical house in the US, right? Whereas in 2018, right, that percentage increases to around 30%, right? So the piece of pie right here, you can see is getting bigger, right? And I would imagine that the mix of the DC, right, or the percentage of DC is even higher in developing countries. The reason being, in developed countries, right, such as US, typical house have big AC loads, such as a big washing machine, a big dryer, right, a big air conditioning, a big refrigerator. Whereas in developing countries, typically the washing machine is smaller, the refrigerator is smaller, right, air conditioning smaller. And so because of that, the percentage of the DC load is going to be higher for developing countries. But nevertheless, what's important here is that the trend, right? The trend is that the DC mix in the typical house is increasing from year to year, and is going to continue to increase, especially with the introduction of USB-C. So then, what is the big deal about this converting AC to DC? Why is it that we cannot just stick with AC, right, to charge our DC load? Well, I mean, it's all good, right, if this process does not have any issue. But the thing is, there is a problem with this process, right? When you charge cell phones or smartphones into the wall, then, as I said earlier, right, smartphones or cell phones running off DC, whereas the wall plug is providing AC. So then you're gonna have to convert from AC to DC, and in the process, right, as you are converting the energy from AC to DC, you're gonna have losses between 17 to 35%, right? So that's the problem, that loss right here, right? So you're losing this amount of watts every time you charge a cell phone, right? And some of you may think 17 to 35% is not big. Well, hold that thought, because if let's just say if you think that 17 to 35% is not big, what about 5%? That's even smaller, isn't it? So I'm going to assume it's very small, 5%, right? It's not even 17 now, it's 5%. I'll make it smaller. And so, okay, let's say that 5% is small, a small loss, no big deal. Okay, that's fine, but let's look at this example I'm providing you with. Let's say that I'm going back to this tablet, right? Tablet internally is DC, and you charge, tablet from AC, the wall plug, right, to this adapter, right, into the tablet, right? And a tablet consumes about roughly 12 kilowatt hour per year. And we have about 760 million tablets per 2016. Now go ahead and do the math here, right? 12 times 760 million. That's going to be a big number. And then the loss is just 5%. Right? Some of you might say that's small. Go ahead and multiply 5% times the product of 12 kilowatt hour per year times 760 million. Go ahead and calculate those, and you'll end up with some big number. Look, so 5% turns out to be just from tablet, right? Per year, right? That 5% represent about 480 gigawatt hour loss. You can see the number is not small anymore, because that's gigawatt hour, right? That's from one tablet. That's from tablet, sorry. If I include, for example, smartphone, everybody has smartphone these days, right? And a smartphone consumes about 4.2 kilowatt hour per year, and they're about 2.71 billion in 2019. Again, do the math, right? 4.2 times 2.71 times 5% gives us the loss, 599 gigawatt hour per year. Is that a trivial number? Of course not, right? So if you add the two, just from these two devices, if you add the two, guess what? The total loss just from those two, right, is equivalent to having 12 units of 10 megawatts power plants running 24/7 for the entire year. Imagine that, right? So that's from 5% loss. What if it's 17%? What if it's 35%? Of course, that's going to be even worse than this, right? So from the global scale, that small loss, represent significant amount of energy being basically energy not being used properly as well. Okay, so that's one reason. Another reason is that why DC will become an important role, or play an important role in the future, is due to the fact that more and more people install solar panels. Right? As you know, solar panels produce DC, right? So now we have DC source right from our fingertip, right? Very close to the house. Now the power plant is not necessarily going to be miles and miles away from our house. We could have a power plant right next to or attached to our house. And again, solar panels produce DC. And as you can see, the number is increasing. In California, for example, every new construction will have to have, is required to have solar panels. So as you can imagine, the number of solar panels being used would be increasing. And then if we have a DC source such as solar panels and our loads are DC, then it would make sense to me, right, if we approach the conversion problem with straight DC to DC, right? Solar panels DC, loads DC, why not just use DC to DC converter, right, to convert the energy from the solar panels into the DC loads, rather than what we are currently doing, which is right here, right? This is a typical method that we are using now, is that from the solar panel, you invert it into AC, right? Because our house is still AC, and that has about 23 to 28% loss. And then from AC, you can read back down to DC, 17 to 35% loss. And because the DC is not matching yet, therefore you have to do another DC to DC with more loss here, right? To me, it makes more sense to do the top one than the bottom one, right? If you have a DC source and DC loads. But unfortunately, nowadays, this is still what we have, right? The bottom method. Something needs to be fixed here, right? And another, I guess this is more like a motivation than a reason, is that, these renewable energy, right? There's so much around the world, and unfortunately, or I should say, ironically, areas that have big potentials in renewable energy are the areas that are not quite able to tap these sources in the most optimum way, right? And so that's ironic, right? And we still have about 1 billion people in the world who still have not had access to electricity, and many of them live in the areas where renewable energy is around them. So it's kind of ironic, right? So hopefully with this technology that we're trying to develop here, we could help them tap into this energy sources easily. And if we look at Indonesia, for example, as you can see, we still have problems with electrification ratio, right? I'm not really looking at the claim that the utility company, tells us, but this is the fact is that we still have dark places in Indonesian islands, right, compared to Java, right there, which is really bright, right? So we need to do something here to help our brothers and sisters living in the remote islands, right? Areas that are geographically hard to reach by the grids, and provide access to electricity using different technologies, right? And another motivation and reason, of course, is that if, for example, this technology could help replace, what many of our, brothers and sisters, right, in remote areas, still using kerosene lamps just for their kids to study, which is not healthy, right? Replaced it with LED and put, at least one smile on their face. That would be, that would make my day. So that is another motivation reason of me doing this. Something that motivates me is that to be able to get rid of this unpleasant experience that I had when I was a kid as well. So when I was growing up, this is the lamp that I used to study, to do homework, right? A kerosene lamp like that, which is again not healthy. So if you can replace it with one LED light, that would be, that would make me happy. All right, so residential DC electricity. For this type of system, I offer or I've started to develop this technology called DC House Project. And the initial goal is to develop an alternative solution for existing rural electrification technologies. How? By using the DC electricity directly to DC loads, and then provide seamless integrations of one or more small scale. So the keywords there are small scale. I'm not really interested in the big scale renewable energy sources. I'm not interested in micro hydro. I'm not interested in wind farm or solar farm. I'm interested in the small scale energy sources. And then this is expanding previous ideas of this electricity from Edison a long time ago, and make it more scalable, reliable, flexible, and so on and so forth, right? And another thing that's important is that the technology that I'm offering follows the bottom-up approach, not the top-down, like the current solution of rural electrification has. It's more top-down. My solution is bottom-up, right? Meaning it could be as small as a solar lighting box. It doesn't have to be a big system. It could be a solar lighting box, just a small box that has one LED light. On a residential scale, it could be a DC house, a standalone off the grid. On a bigger scale, it could be a network of DC house, right? So it's really flexible and scalable. And my philosophy when it comes to rural electrification, solution to rural electrification is that one size does not fit all, right? The solutions that we have these days in many areas will not fit, will not be suitable, right? There's some areas, for example, who probably have like small stream of water, but then they could not do anything to it. They cannot tap the power because, for example, for micro hydro technology, you need a big river stream, right? You need a big water stream or a stream of water, right? You need big rivers, basically. But what about the small, small creeks, right? Small water streams, right? Those are something that we can tap into as well, right? So for those areas where don't have, big rivers, they can still, tap those resources, right? You convert it into electricity. Same thing with the wind. Same thing with the solar power, right? So we need an alternative solution. So I'm not saying that the current solution is bad. I'm just saying that we need to complement the current solution with an alternative solution. And that alternative solution should be reliable, scalable, multiple, expandable, reachable, and flexible. And I'm not going to read off all of these because that's going to take time. But these are the features that I'm offering with the technology. And here is an example of simplified block diagram of the DC house project that I'm trying to develop, or I've been developing since 2010. You can see it has three different components: the source or the generation side, the interface side, and the load side. Right? The generation side consists of small DC sources. Again, the keyword here is small. Right? I'm not interested in big generation. I'm interested in small generators. Right? All kinds of small generators. And then when we have small generators, right? Doesn't matter, right? If you have small, but if you combine them, then those small ones becomes big. If you combine all of the small ones, then you have a bigger energy to go into the house. So we have to have a way to combine these energy sources, small energy sources, into one DC bus. And this technology to combine them is what I call MISO. Stands for multiple input, single output. So if you are familiar with some Japanese food, this is a famous Japanese soup, right? It's called miso soup. So, but this miso is, again, it stands for multiple input, single output. So you have multiple inputs from small generators into single output of the DC bus to the DC house. And so, sorry. So then, in terms of technological development and also breakthrough, you could look into any one of these three components, right? You can look at the generation portion of it, interface portion of it, as well as the load portion of the project. And I'll give you some examples for the generation side. There's so many challenges we have there, because again, the objective here is that we want to develop technologies to be able to again tap small renewable energy sources, such as small stream of water like this one, right? This water stream is not going to work for micro hydro, but it will work for a small generator, such as this one right there, the one that this picture is showing, right? Portable nano hydro, right? An idea that I had some time ago, but I wasn't able to develop one. But then somebody in Europe, a group of people in Europe, actually already make this as a product. So this is a generator that you can put in your pocket or just carry around, I should say, carry around. And then if you see a small water stream like this, you can just dip it into this water and it'll start to turn, and it'll generate about 25 watts. And that's enough for a DC house project system. That is enough, right? We don't need 25 kilowatts. We don't need thousands of watts. We just need 25 watts. Same thing with another challenge is, how do you reduce the cost of the system, right? Generator is expensive, and especially low speed generator is very hard to come by. So then one way to do it, to keep the cost low, is by using used cars, right? There's used alternators from the car, and you can rewind inside so that you can actually make your own low speed generator. And it'd be good to have like a YouTube video, right, showing how you can actually do this. If you have used alternators not being used, you can always rewind them. And this is something that we've developed at Cal Poly, which I call play park generators, right? So again, small power, but it's still useful if you can combine them. For example, if let's say that you have this swing, right? And so if kids are playing the swing, as they are playing the swing, then we can generate power from the motion. Same thing with the seesaw, right here. As the kids are playing the seesaw, we can collect the energy from the movement of the seesaw. And finally, this merry-go-round right there. Same thing, as this thing spins, you can collect the energy from there, while the kids are having fun. Again, small, but it could be very useful when you combine them into one. And another aspect that I don't want to forget mentioning is this brain. And this is another thing that we can develop, right? If you want to help or contribute to this project, you can also start, thinking about how do you create the brain for this system, right? Basically, what we call an energy management system, EMS, right? That can monitor, control, and then continuously read, the status of every single point in the system, right? And that's the generation side. On the interface side, remember MISO, that's that technology right here, right? That portion right here sounds easier or looks easier, right? When you want to collect all this energy into one, that looks like an easy thing to do, but trust me, it's not. I started developing this technology since 2011, 2010, and took us about 5-6 years to finally find the key. And then, alhamdulillah, we got the patent, US patent for that converter, multiple input, single output. That's just recently, 2019, I believe. And that's the picture of the MISO converter that we patented in the US. And this is a picture from a local newspaper. So I was celebrity for a short term here. And here's another picture of the EMS, right, the brain that I was talking about earlier. On the load side, there's a lot to explore, right? There's a lot of challenges with the load, right? One of the challenges of DC is that in DC, loads are not standardized. In AC, they are standardized. Right? If let's say in Indonesia, if you buy appliances, home appliances, and for sure that home appliance would be running off 220 volt AC, right? So they're all standard. But DC is a different story. If you buy DC loads such as DC fan or DC TV or DC refrigerator, they run off these different DC voltages. Some of them are working on 24 volts, 12 volts, 5 volts. So when you have multiple or many DC levels, then what do? Are you going to provide multiple volt plugs? Of course not, right? That will not be wise, because then people will get confused, right? Which volt plug should I plug this load into, right? So then the idea that I came up with is, why don't we develop a smart volt plug, right? Where you have only one DC volt plug, and this DC volt plug is smart enough to figure out if you plug in a load, DC load, then it would be able to determine how much load, how much voltage it will have to output, right? So that's called smart volt plug. Another challenge for DC is the protection. In AC, the signal inherently will go to zero. It will cross zero, right? So it's easier to break the circuit, break the power, or break the energy, interrupt the energy. But with DC, the energy the electricity is flowing continuously, like flat. So when the electricity is flowing continuously, then it is harder to break the energy, to interrupt the energy, right? So therefore, it is a challenge, right? It's one of the, I guess, drawbacks of having DC is that DC is always continuous, and therefore it's harder to protect. And I looked into 2 different type of protection here, and of course there's still work to do. One is for the DC breaker, and the other one is for DC arc fault circuit interrupter. Right? These are the circuits that we developed at Cal Poly. Oh, by the way, this is the smart wall plug system that we attempted to build at Cal Poly. Still not good enough. I'm still not happy with it. So we are still working on improving the technology for smart wall plug. That's basically what it is right there. So you have the circuit or the hardware behind the wall plug. So when a DC load is being plugged into this wall plug, this brain right here is able to determine how much voltage output it's providing to the load. Okay, so examples of how we can implement DC house. I've seen pictures of this, right? Where in Indonesia we have villages that have clustered of houses like this. So the houses are clustered together, just like this, right? As you can see. If that is the condition, then this would present ideal condition for having DC house network, right? What I meant by that is that imagine if every single house is a DC house. It has its own solar panel, it has its own energy storage, right? And then between houses, we can connect those, right, through this centralized DC bus. And by doing so, we allow these houses to exchange energy, right, back and forth. So that's something that we can still develop, or we are still in the middle of developing the, the technology for DC house network. This next
2 more
one,
minutes, Professor.
I'm sorry.
Or 2 more minutes, Professor.
Okay,
I'm sorry.
yes. That's okay. No, good. Thank you. And this shows you the benefits of using DC house network. It's more reliable. If you do the conventional technology, if the, for example, just as an example, if the source is down, the entire houses or village will be down, right? Will be blackout. But if you have a DC house network like this, if one solar panel is down, then every single house is still on, right? Because this house can still be supplied by the other houses, right? And another example, which is a very exciting opportunity, is what we call hybrid AC/DC, and we are still developing this. And the reason why I want to develop this, because every time I'm making presentation about this technology, people will ask, can you implement this technology or adopt this technology into urban houses, houses in big cities? My answer is yes. In order to use the technology, you have to mix it with AC. So I envision that in the future, houses in urban areas in big cities will have two different electrical systems, AC and DC. So AC straight to AC loads, DC straight from solar panels straight to DC loads, but there is a crisscrossing path. So AC can cross to DC and DC can cross to AC. Just in case the utility from PLN is down, the AC loads can be supplied from the DC. Likewise, if the solar panel is down, then the DC load can be supplied from PLN. Okay, since the time is almost done, quick show of prototypes of the DC house that we have so far. One at Cal Poly, another one at Pajajaran University, and then in the Philippines as well. And they're actually doing something with the DC house here, and also in Jatinangor Regency office. As you can see, I am combining wind power with solar power right there. Okay, I think I'm almost done. So a lot to develop here. So if you're interested in developing or helping out with this project, you can definitely do that. And as you can see, there's a lot still to do. And as a summary, I'm not going to read the whole thing here. My point of this presentation is that DC is up and coming, and I believe that DC electricity will be the future of this electrical system. It will play an important part, integral part of electrical systems. Although I only presented hardware, some people ask, what about the software? There's so much to also develop in the software side, and I'm not gonna list those here, but you can see it here, and I'll share this presentation with the committee so you can get a copy of this. References of this presentation for DC House. And finally, if you are interested, we have this website, dchouse.capoli.edu. Feel free to contact me if you're interested. And with that, thank you so much for your attention. And hopefully, this interests some of you in participating in the project. So with that, thank you, and Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor, for your informative and interesting talk. We all know time is not enough for such an interesting talk from you. But this is the future we want. To be honest, we all very proud to witness that you, as an Indonesian, have contributed in being the important part of U.S. electrical management and research. This should be a great inspiration and influence to us to reach such milestone that you have. All right, so ladies and gentlemen, we are now come to the question and answer session. One question only for now. Sorry for that. So you can raise your hand or literally raise your hand in front of the camera. Once you're in spotlight, don't forget to mention your name and country, then ask your question. Please do so immediately. Anyone, please? Okay, if no question from the participants, I would like to ask a question to Professor. So this is very interesting, Professor. With such an increasing DC electrical usage throughout these years, could you estimate when will we fully use the DC source? I mean, there's no more AC source. When will that be?
Okay, thank you. The answer to that is never, unfortunately, right? So as you can already see, around us, the infrastructure for electricity is all AC. It goes back to the history, right? The war or the battle between AC and DC, between Edison and Tesla, Westinghouse. And as we already witnessed these days, right? Reason why we have all of this AC system, AC infrastructure, because Tesla won the battle. Right? DC was introduced in the U.S., at least in the U.S. It was introduced by Edison, and at the time, Edison got beat by Tesla, not because the electricity, the idea is bad. I don't think it is. I think the idea is better than AC, in my opinion. But unfortunately, back then the technology for DC could not provide provide the benefits or leverage the benefits of DC, whereas AC by Tesla, right, at the time they have a way to increase to actually minimize or to improve or to enhance the performance of electrical system by using transformer, right? So they have the technology. AC has the technology back then, but DC, there was no technology to step up or step down DC voltage. That's why Edison got beat by Tesla. And that's the reason why we have all of these AC system around us, very predominantly AC. And so the answer to your question would be never, because then it would be so expensive to replace all the infrastructures to DC. So what can we do? Well, what we can do is that we can complement. So what I'm proposing here is that we are complementing. We are not replacing, but we are complementing the current AC systems with DC. That's why I said earlier, I would envision that in the future, houses will have a mixed electrical systems, AC and DC. Because again, I don't think we can get rid of AC. Yeah.
All right, Professor, thank you very much. There's one more question from, please, Pak Wahyudi Hasbi, you can ask the question, the last question for today's session, please.
Thank you so much, Professor Taufik. Really inspirational, very influenced us for your project. I have just maybe an easy question for you, and you may have the answer. I think. What do you think about the most challenging to implement this project, especially in Indonesia? Because I believe that we really need this kind of technology. So what do you think about it? What is the most challenging? And then is there any part that Indonesia also can contribute to your project actually? So thank you, Prof.
Yeah, that's a very good question. It's not an easy question, by the way. Yeah, always, anytime I hear the person saying it's an easy one, but it's usually not. Okay, so the question is, what is the most, difficult challenge, right? I think what I'm offering here is, a change, right? When you offer a change, then some people are reluctant to change it, right? And it's reluctant to change the mindset. And so I think at this point, and not just in Indonesia, in the US, the same way, right? Not until industry participates, that's when I believe we can have the momentum to actually implement DC. But as long as the industry is not interested, then I think it's going to be very hard for us to be able to implement this technology. So that's one thing that we need to do, is that how can we get a buy-in from the industries, right? I could, for example, invite or get the interest from some universities or from research agency such as BRIN. Right now, they changed to BRIN, right? There's no more BPPT or LIPI. Now it's BRIN. I can get their interest in this area, but as long as the industry is not buying in on this, it's going to be tough. So that's one thing that we need to figure out how. I don't know how in Indonesia. In the US, we just have to find investors who are interested in doing this. And I think I don't really want to compare Indonesia and US, Indonesia and US, because it's not apple to apple type of comparisons. In the US, it's kind of, I would say, easier to, in one aspect, it's easier to try out this technology because DC loads are quite common, more common than Indonesia. One example is, RV, recreational vehicles. That's very common in the US. RV is basically a big car, a big car that a lot of people have, so that in the summertime they would take their family around it, to travel. And inside this car, there's a lot of DC load because car is run off battery. So finding DC loads not that difficult. But in Indonesia, it's different, right? Probably having more difficult times to find DC loads. So that's one challenge, I guess. So there's so many challenges that we have to overcome, in Indonesia, in order to be able to implement a new technology, not just DC house, but any change, any new change. It's very hard to actually get people to to use or to start using. Okay, so that's my answer.
Yes.
Thank you
Very much, Professor Taufik and Pak Wahyudi Hasbi. Thank you very much for the question. This is a very interesting topic, the topic for the future of power in Indonesia and the world as well. But unfortunately, we are running out of time. Thank you, everyone. A further question can be directed to Professor Taufik's email, right, which he has been shown previously. We are now at the end of our first talk. Thank you, everyone, for the participations. Most of all, thank you to Professor Dr. Taufik for your valuable knowledge shares. Thank you very much, everyone. After this, we are going to the second keynote speakers. Right. Hello again, everyone. Thanks again. We are now in the second keynote speaker. Allow me to introduce the second keynote speaker. He is Professor Chen Si-chung, PhD. He is a distinguished professor in Southern Taiwan University of Science and Technology in Tainan, Taiwan. His main research is design of advanced high-tech assistive device, BCI control, microcontroller control, application of image processing, and design of medical instrumentation. He has published many papers related to his research interests in outstanding journals and conferences. He also holds many invention patents in Taiwan, China, and US. Please welcome Professor Chen Si-chung, PhD. The stage is yours. Professor, you can unmute your microphone first. You can, yeah, but your Your microphone is still loud. Okay.
Can you hear me right now?
Yes, Professor, loud and clear.
Okay. Can I try this? Is it clear right now?
Yes, it's clear
yes,
now.
Okay.
You will present around 30 minutes, Professor.
Okay.
So
right now,
yes.
we want to start right now?
Yes, please. Yes.
Okay. First of all, I would like to say hello to some key persons in the conference, including the rector of the University Negeri Malang and the dean of the engineering faculty and the chairman of the ICEEIE Indonesia section, the head of the electrical engineering department. The general conference chairman, Dr. Elham, my best research partner before. Okay. So, ladies and gentlemen, good morning. I'm Professor Shizong Chen. I'm from Southern Taiwan University of Science and Technology. Later, I will use the acronym STUST to replace the Southern Taiwan University of Science and Technology. It's my great honor to attend the 7th ICEEIE conference as a keynote speaker. Thank you for giving me this opportunity. Okay. So I will share my presentation PPT.
Yes.
Can you see the PPT right now?
Yes, Professor.
Okay. Okay.
Great.
Before I start my presentation, I would like to introduce my background and the STUST. Here is the outline today of my presentation. Okay, this is my background. Okay, you can see the my information here. I think you can find out an important truth from this information because I have many years of experience. So I'm an old man, right? So from this information, you can find out my major two research field. One is for robot control. The other is for assisted device development or biomedical engineering. And I also play the roles of two kinds of roles. One is a senior supervisor of TRIS. TRIS means Taiwan Rehabilitation Engineering and Assistive Technology Society. And the other role is the member of the review committee of Central Taiwan Science Park. Okay, so for review some proposals accelerating bio research. Okay, I just say STUST. STUST, my university is located at Taiwan, Tainan, Taiwan. And Tainan is a very oldest city in Taiwan. There are about 1.8 billion population and about 2,000 temples and shrines. She is the famous city of the snacks. You can find many kinds of countries, many different countries' food, including Indonesia's food. Okay. Society. social science, and the College of Digital Design. More than 500 faculties, including professor, associate professor, and assistant professors, and more than 17,000 students, including undergraduate, masters, and PhD students. As you can see, this is the view, campus view of STUST. She's a very beautiful university. Okay. Now we want to start our presentation about the topic. My topic is new application of ICEEIE technologies. Then we can find you can find the most of ICEEIE technologies are applied in the fields of industry or engineer science for mass production. Okay, and the new application I want to show you the trend of the new application is amplify the ICEEIE engineers vision and extend the new application to the field of the medical science. For example, assisted device, assisted technology, and the biomedical engineering. And new application will need the interdisciplinary teamwork. It's very important. Let me show you some research scenario between the traditional and the new application. As an ICEEIE engineer, your research might be related to industry robot. Is it possible to switch your application to medical robot? Yeah, that's one kind of thought to invoke you to get into the application field. Okay, as an ICEEIE engineer, your research might be related to image processing and recognition. Can you switch your new application to medical image processing? For example, MRI, CT image, and X-ray image from your original traditional image processing, like face recognition or movement recognition. Of course, the same. Your research might be related to mobility development. So can you switch your application to the assisted device like scooter or electrical wheelchair from the car or motorcycle by using your same technologies? This is a communication device. So your research might be, if you are you are original in the communication field of ICEEIE. So your research might be related to the stereo speaker or earphone or iPad, cell phone. Can you switch your new application to hearing aid communication board? For example, like this. This scenario helps us to think further to change our application. Okay, what is assistive technology? device for people with disabilities or elderly populations. People with disabilities often have difficulty performing activities of daily living. So the issue of AT is to develop some device for this kind of people, elderly people or disabled. Okay, what is biomedical engineering? Biomedical engineering or medical engineering is the application of engineering principles and the design concepts to medicine and biology for healthcare purpose. So the object of BME, biomedical engineering, should be people, not only elderly people or the disabled. So the fields of BME is to seek to close the gap between engineering and the medicine. The range of BME is broader than AT. The criteria is higher. For example, the level of FDA regulation is tougher. Okay, let me show you two famous assistive device, assistive technology. The first one is about Intel ACAT. Intel ACAT, what is Intel ACAT? ACAT means Assistive Context Aware Toolkit. I think everybody knows, have heard the name of Stephen Hawking, Dr. Stephen Hawking. He died 1 year ago, 2 years ago. The ACAT is an open source platform developed at the Intel labs. So Intel integrate a teamwork to help the Dr. Stephen Hawking to enable Dr. Hawkins. Dr. Hawkins is the people with motor neuron disease. So they help Dr. Stephen Hawking to have the full access to the compatibilities and the applications of his computer through very constrained. You know, Stephen Hawking is a amyotrophic electrosclerosis, in short, ALS. So she has the ability. She has lost many abilities. So his interface is very constrained. So ACAT can help Dr. Hawkins to finish some paperwork on the computer by himself. Okay, so in the ACAT, including the functions of keyboard simulation, word prediction, and the speech synthesis, and editing, documents management, navigating the web, and accessing the emails. So many functions can support on the platform of ACAT. Let me show you the demonstration. Maybe you can understand. First, you can see the interface GUI of ACAT. simple switch to control the interface. So this switch is very easy. Just button or switch. Even you can wear nothing. Just use your face image. So you can control the character what you want. The character panel will be scanned row by row, column by column, like this. And then you can choose what you want. Using this switch to choose what you want. Okay, then you can finish a word, and the word maybe you can use an agent management. He has the word partition. If you want to type name, so you have type NAM, the last character E, the prediction function can find it for you. Okay, so I have a demo video for you. Because time limit, so we just show a paragraph of the video. Dr. Stephen Hawking just can move his chin or use his eyes blinking. So he has very constrained function. You can see the subject is moving his chin to select the animation, character animation. Blink sensor. Okay. That's the first example for ACAT. The second one is high-tech SAT device. So we call that a brain-computer interface research. You can see two paralyzed subjects move the robotic arm with his or her thoughts. So it's a very advanced research. So we can see the demonstration.
In this paper, two people with TEP happens is that cells in the motor cortex and other parts of the brain, whether they continue to function the same way years after that original injury. It is possible for people to use their thoughts to control devices, either a computer or a robotic arm. The way that happens is that we implant a tiny sensor, just about the size of a baby aspirin, just into the surface of the brain, and that sensor pick up the electrical impulses from a bunch of neurons. And each of those neurons are like radio broadcast towers putting out impulses. And when they get to the gave us all pause. She reached out with the robotic arm. She thought about the use of her own hands. She picked up that thermos of coffee, brought it close to her, tilted it towards herself, and sipped the coffee from a straw. And that was the first time in nearly 15 years that she had picked up anything and been able to drink from it solely of her own volition.
There was a moment of true joy, true happiness, and it was beyond the fact that it was an accomplished.
Okay, we see the next two. This is the second generation of the BCI.
Two micro electrode arrays in his brain, and the arrays.
You can see two tiny sensors
cells in the brain
were implanted in the brain.
Algorithms developed by Dr.
So it's very dangerous.
These encoding algorithms would then be used to move a
This part of work, we need the doctor or physician.
Now we have a entirely new area in the brain.
We just saw the paralyzed woman. She has only one tiny sensor, and this second one subject, he has two tiny sensors in his brain.
Capacity to become more independent than they are now.
Some activities take more concentration than others. Some we found out that having a small conversation helps the activity move along smoother. Some I gotta be quiet, and if I get frustrated, everything just goes downhill. The activity won't work at all.
We are making huge strides in overcoming a lot of neurologic disease. And these very important early clinical trials could open up and provide hope for patients with all sorts of neurologic problems, such as stroke, brain injury, ALS, even multiple sclerosis.
It's great to see this technology.
Okay, so these two famous example of AT, I think maybe they can evoke your interest in AT research. So why we choose AT as our presentation topic? Because some reasons, right? Here we have an organization called that World Intellectual Property Organization. This organization just published a report. They find the significant growth in assistive technologies as they find the greater application in consumer goods. That means assistive devices are converging with consumer goods. So the production will combine together. So, and the other report from globally elderly and the disabled assisted device market size, we can see the trend from the marketing size of the trend from 2018 to 2027. The marketing size of AT is expected to double in the next decade as population aging. So this is the reason why we choose the assistive technology. And also NIH US they give a report. The report offers the details of global aging phenomenon. You can see the curve for the older people over 68, 65, 60. Pressure will result in this kind of a result. So the young people maybe cannot support so many other people's pressure. Okay. Global trend of the assistive device market. We just see the report, and we know that increasing aging population supporting growth of the elderly and the disabled assistive device market. And the other reasons is initiatives of government and the independent agency favorably shaping the elderly and the disabled assistive device market scenario. So in Taiwan, our government is encourage us to do this kind of research. And the third, not only the unmet needs from elderly people or the disabled are getting more, but also consumer electronics and assistive products are converging, meaning even greater commercialization of this technology. Finally, we can find if you are a social scientist, then maybe you will think that this is very important. The Convention on the Rights of the Person with Disability, we call that the organization, we call that CRPD. They recognize access to assistive technology as a human rights. So to help the elderly people or the disabled is our responsibility.
3 more minutes, Professor. Sorry.
What? Okay.
3 more minutes. You have 3 more minutes.
Okay.
Thank you.
So, if you are a ICEEIE engineer who is interested in AT, what will be your challenge? SWOT table will give you some help. Strengths, because you have the same specialty and the skills you have already have. You just need to expand the field of application. You might find some creative ideas to apply research fund and from government and the file patents. That's your strength. A weakness, ICEEIE engineers need to integrate team members to work together, especially doctors and the medical staff, especially medical training, physiology, and the knowledge of taking care of the aging people. An opportunity we just told you, the marketing is growing. So new application, new market, and many unmet requests from customers. And patent filing is relatively easier than the others. And final, stress. Stress is very important because safety problem is our big problem. So how to ensure that the product is safe So safety program and the FDA regulation are the key criteria if you want to promote your development to become a commercial product and the mass production. So this slide show you the access device for the people with visual, hearing, voice, speech, or language disorders. They are commercial. Assistive device, like the skeleton unit suit. This one is developed by Israel. This one is developed by Japan, and this one is developed by Taiwan. And the other hand prosthetic and leg prosthetic, all of these are high-tech assisted device, but they are also commercial. So you can buy it in the market, but expensive. So you have seen many kinds of different assisted device example. And I want to show you last some assisted device developed by Taiwan by STUT. So but at the left side, you can see two kinds of product developed. We call that the Morse code controller. The disabled can use this kind of product to replace your keyboard or mouse, similar to just we saw the ACAT, right? So you can see the demonstration video. The subject just need to open or close his mouth and control the period of the open or close. Then he can type Morse code. And this one is BCI interface example.
各位好，现在为大家解说一下，就是我的脑波输入法。
Okay, because of time limit, we will stop. And this part, the other BCI control robot. It's a academic and industry cooperation product. Okay, and this one is AT device, but for the creation for entertainment only. Okay. Finally, I want to say that change your mind and change your word. If you are a ICEEIE engineer, we can amplify our vision, then we can see another beautiful world. And thanks for your attention.
Okay, thank you very much, Professor. It's such an inspiring presentation.
Yes.
Right, this technology you presented made us grateful that in the future there will be no more disabled people, in the quote. Everyone are functional to the community. So and I've been a fan to such technology. Once in a while, I was imagining to play a game controlled and navigated through thought, through brain. It should be interesting, right? Right, ladies and gentlemen, we are now in the question and answer session. The same procedure applies. Just raise your hand immediately. All right, I found one.
Yes.
Professor Aji Prastya Wibawa, please, you may ask the question to Professor.
Thank you, Mr. Moderator. Professor, I have a question for you because I'm just curious because your research involve human. Yeah, it is very interesting topic of assistive technology, but as we know all that this kind of research is involving human. So my question is, how about the ethics or the consideration about using or asking a human as the research object, especially when I saw your video about implanting sensors in the brain. It is such a scary thing in my opinion. And are they voluntary or is there any contribution for the object or when they involve in your research? Thank you.
Sorry, I can very understand your question. You mean the sensors, the sensor in the brain, right?
Yeah. But what I mean is, if you ask the person to implant the sensors in his or her brain, are they volunteering, or you give them such a compensation or something for doing to involve in this such research? Thank you.
Actually, our BCI research is different from the BCI research in USA. We just wear a head cap, or just attach some electrodes on the hair.
Okay.
Not hair, not a scalp. Okay, but we don't put any sensors inside the brain because they need the doctor to do the surgery. Okay, so we just use the electrodes on the scalp. We wear the head cap. Okay, so we use some gels to help the conductivity.
Yeah.
So we can measure the signal. Okay, no problem.
Okay, so basically the result is not dangerous, right? It is safe for people.
It's okay for any people.
Okay.
Yeah.
Okay, thanks, Prof. Yeah.
Just clean your hair before the month.
Okay.
Yeah.
Like this.
We must keep the hair clean. Yeah.
Okay.
Otherwise, your signal will be very noisy.
Okay. Yeah. Thank you.
Yeah, thank you very much, Professor Aji. One more question from me. Do you, yes, are they voluntary doing such thing like the disabled people when doing the research? Are they voluntary, or you give them reward or something? You pay something to them?
Most of these subjects, we call that subjects, okay? They are voluntary, but we still have REC or ICEEIE committee to audit what we done. Okay, so sometimes we don't give any money. We just give some small gift for return
for their favor.
Okay, so we don't pay a lot of money because our project is
Yes, thank you, Professor. Because of the time is over now for the session, I would like to send grateful for your talk. This is very inspiring for us, and I hope that we can continue contributing to collaborating each other with you, with Dr. Ilham. We have the lab specifically built for Dr. Ilham research in brain-computer interface. We hope we have a better collaboration in the future. So see you soon, Professor Chen Sichung. Thank you very much.
Wish you have a successful conference. And if you have any question for me, you can email, okay, or you can tell the Dr. Ilham, okay.
Right. Thank you very much, Professor.
Thank you very much. Thank you.
See you.
Yeah.
Okay, everyone. Let's go on to the next session. Our third keynote speaker is our lovely Dr. Engineering Anik Nur Handayani. She is currently the Secretary of Electrical Engineering Department in Universitas Negeri Malang. Her main research is biomedic and intelligent assistive technologies. Quite similar with previous keynote speaker, she has published many papers related to her research interest in assistive device for visually impaired person. She holds invention patents such as EcoLab classroom for convolutional neural network practice and one patent for dynamic mobile braille touch. It would be more interesting and engaging to listen to her talk about these orange technology. So allow me to invite Dr. Anik Nur Handayani. The session is yours.
Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, good morning everyone. Terima kasih Bapak Harits as a moderator. Before I start the presentation, let me introduce myself first. My name is Ibu Anik Nur Handayani. And then I'm one of the lecturer at Electrical Department of Universitas Negeri Malang. And also here I attach my email. And right now I'm interested in Intelligent Assistive Technology Laboratory together with Bapak Ilham Ari Albet and Budia Lestari. And also this presentation related with Professor Chen Sinsi. Thank you. So today, my presentation talking about orange technology and application due to the topic of ICEEIE technological breakthrough for greater new life. Okay, here is the table of contents of my speech today. Starting with the introduction of orange technology, and then scope, and then we have H2O model, orange index, and research area of our experiment. So firstly, I want to introduce the term of orange technology. The growth of industrial revolution had a significant impact on people lifestyle. We know that the rise of technology also linear with the rise of the economy and technology, and a lot happens because of the revolution of industrial and biotechnology. So the technology is now widely regarded and is important tool for each of human individuals to save the time, to improve their health, happiness, and care. So the term orange technology is founded by Dr. Jing-Fa Wang from Taiwan, and it's reversed to a new concept that depicts all technologies relevant to human for the health, happiness, and care based on the input from the sensors and communication, control, and numerous software technologies. Right now, the famous term that we know is the green technology, and it's very famous, and all of the engineers have to hear about that. The green technology refers to the environment which commit to lowering carbon emission and conserving the energy to order to improve the living conditions. The temperature of the huge orange technology that interprets humanities represent energy that cares about how to live a happy and healthy life. So here is the figure. What is the relation between green and orange technology? So we can see from the blue color, the technology industrialized make effect from the global warming. So as a human and as engineer, we have to think of how to protect using saving energy and reducing carbon emission, using environment development to have a good natural environment. How about the impact for the humanities? How the impact of humanities, we can see that from the technology industrial, the gap between rich and poor, the financial crisis, and also there are a lot of person that we have to taking care, just like this disabled person have to. So the energy here is how to develop system that could measure the happiness care health by using economics of happiness, physiological geography, cultural psychology to have a good living as a civilized living. Okay, so therefore from green to orange will be reflecting how the development of technology and could ensure the quality of living environment more comprehensive and also to boost the health and the happiness. Okay, next. Sorry. Okay, here is the scope of orange technology. As we know that the orange technology came from the several background. So the orange technology could built by his or her own self, but there are background that have to symbolize each other, just like from biomedical engineering, computer science, electrical engineering, design technology, psychological science, cognitive science, and then social science. Okay, what kind of the thing that measured by orange technology? There are three models that measured by the orange technology. Firstly is happiness. By improving happiness and life quality and take data from the health science expert, we could measure the happiness with the satisfaction index. And for health, by improving health, we could take data from health science expert. We could measure the health of index. And the last O from the H2O model means offering, carrying, warming, and we call it as OCW, to improving human machine or computer interaction by taking data from the health science expert to measure the care index. Okay, next, here is the orange index framework for the happiness. I take this from the Professor Jing Fawan from the Taiwan. So the happiness model here is the happiness model. We can see from the diagram, the happiness model need a user input and predefined database. And most of time, the input is measured from the bias signals or behavior or user, just like the blood pressure, the heart rates, the gaze, and the laughter. Thus, how to combine data and determine happiness status become a challenging task for the happiness model. And next is the healthy model. The health model is commonly used in medical expert system. The interface, when a user inputs a query to the interface, the system then consults with an expert or doctor. After merging the opinion of the expert into knowledge database, the system replies the use with a proper response. So that is for the health model from the Orange Index framework. Okay, the third is OCW model for the offering, carrying, warming. Here we can see from the block diagram that the offering, carrying, warming model plays a key role in orange computing since it involves whom, how, and when to give proper feedbacks. It also requires semantic understanding techniques and delicate human-machine computer interaction. That is the framework from the OCW models at Orange Index framework. So I will explain several research areas, happiness model that built by our student at the electrical department. Here is the example I found for the happiness. We could see here is the development of related learning media based on mobile phone, G2ME. This is the first interesting for the happiness model by using a QWERTY handphone for the visual impaired person. By the handphone, we called it handphone, still using the QWERTY input. They could study by himself by using this media. So from the handphone, I call this is just handphone because there isn't smart for the touch technology. The VIP person could use the media for the learn self-study for the Braille. And then here is they can use some several module for the study, and then they can input the area of the QWERTY for the Braille dot. And the aim is the visual impaired able to operate the mobile phone. That means using QWERTY phone for their they can learn for the Braille at every time and everywhere. And then by the growing technology, we can see that the Braille text could not use there for study at everywhere and anytime, and then they can use mobile phone for their study at home or at their own town. And then we call this system is a mobile Braille touch. Why we call this as mobile Braille touch? Because we're using smartphone by the touch technology, and then they can learn the material for the just like writing, calculating, and so on with using this MBT. So just like the example, we were conducted for the mobile Braille touch for the visual impaired person. So here is the idea: they can use the mobile phone, and then by touch using their finger, and then they can enter the system by using the choose tumble, and then for the exercise, and then here we can see button for the setting, button for the translating, and then here also we can see button for the menu list and help. Not just they could study by using their finger, touch the screen as a Braille touch, but also there is an annotator that translates from the system to the text to speech. Okay, next. Okay. From the mobile Braille touch, there is a region of interest that could touch by the VIP. For the example here just the region of interest for the dot matrix for the VIP person. So if he touched at the middle of the area, so they couldn't find the Braille touch. And then we improve by using the mobile Braille touch, so they can touch everywhere in this region of area at the mobile phone. But still the aim is how to learn, how to exercise, and then how to write, how to calculate by the mobile Braille touch. But we call it a dynamic because they can touch everywhere for the dot matrix of the Braille. Okay, next is the implementation of a Braille to speech prototype application as a self-study tool for VIP. This is one of our students that right now study at Saga University, taking the doctoral degree. So we can see from the picture that this design of application aims to help VIP in learning Braille independently based on the drill and practice method. So the application translates the scan Braille here and then processing by the application, and then the output will the system will try to translate all of the print Braille template by the scan to the speech. So they can scan the Braille, and then the Braille area will process by image, and the output will be by speech. Okay, text to speech. Okay, next is health model. So this still conduct from the several students of us, and also one of our counterpart from the Saga University, Samu Fukuda Sensei. So the aim of this SS child with cerebral palsy is we want to develop really interesting for the child with cerebral palsy, how to make their treatment for the cerebral more happiness by using a robot. So we can see the cerebral palsy. Some of the child have on good condition, just like they couldn't walk, just like this, and then some of them couldn't use their performing by using oral, and then some of them have to use the physical treatment because there is not good condition for their bone and so on. So here is we want to make some system that we use the robot to make the happy treatment for them by using camera from the monitor. So here is the monitor to display the evaluation of children's arm movement during arm therapy. And then here is the nurse as a guide and evaluator to the children while conducting the arm therapy. And then here is the children with cerebral palsy conduct arm therapy in front of the camera using Kinect camera, and the arm robot as feedback to the children that move based on the arm movement. Here is okay, thank you. So here is the example. We take some image from the children with cerebral palsy and then normal children, and then we make some image processing, and then after we have a good model by using AI, and then we injection the data to the robot, and then the robot will make some movement that the movement is based on the treatment of the children with cerebral palsy. How about OCW model? We use VIP tracker by also some counterpart from Saga Daigaku Japan. With VIP tracker, it means visual impaired person tracker. So if the person with the low vision want to mobile by himself, they can use the VIP tracker, and then the family could track them everywhere by providing the area And then the velocity information, I mean, which the dot, it means the X and Y position of the VIP track, and then provide the velocity, and then what kind of vehicle that used by the person with visual impairment. So we already make some experiment here with the VIP person. Also, a mobile application system for assisting visual impaired based on real-time object detection. So the idea is how the VIP person could went or going to the supermarket, and then they can buy just like vegetable, fruits at the supermarket by using our navigation, real-time detect object for the VIP person. So we using accelerometer, marker location, and safe location, and then they can buy whatever they want at the supermarket. And the last is sign language recognition. We still ongoing with this sign language recognition. The aim is we want to make some how to build the system that the system could provide the sign language for the deaf person to the public. I mean, some of the public could not make some conversation with the deaf person. So we want to make sign language recognition here to make the deaf could communicate with the normal person. So we, from base first experiment, we already could make some result sign for this example of sign. It's classified as H. This is one of the example result and already validated by several teacher at SLP Tunarungu at Malang, and then we still doing for the application. That's all for me. Thank you very much, and Assalamualaikum warahmatullahi wabarakatuh. Back to Bapak Haris.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Rani. That was really interesting and visionary. I once thought that VIP you had was abbreviated from a very important person. Instead, it was in common sense. In common sense, this visually impaired person is important, right? Therefore, there should be carefully treated. However, nice talk, Dr. Rani. Thank you. Right, ladies and gentlemen, we are now in the question and answer session. You can raise your hand, and don't forget to mention your name and country for this question Q&A session. Please do so. Anyone? Let's see. Right. No one is asking. Let me ask you a question, Dr. Rani. When you read the hand sign, is that for learning, right? Is it for learning or for translating?
For translating.
For translating. Do you have to use that green screen, or do you just use wherever you want to translate any hand sign?
So right now we just we still conducting the experiment by using the camera. I'm sorry, I have to say Kinect, and then we still using for the PC base. If we have a good model, then we could translate it by using application and using the mobile phone camera. So we still conducting by using Kinect to get the best model for the sign language recognition.
All right. So it should be a complex process doing so, because In my narrow knowledge about computer vision, I think there will be a lot of noises.
Yes.
Image noises that you have to handle during the training process, etc. So how about this? You said that in the orange technology, you expect the users are happy.
Yes.
Is this technology sensing such happiness and like predicting whether the user is happy or not? Is it like that?
Yes. Mostly our experience are conducted in Indonesia, and then after we showing this product and this system to the VIP person, to the dev person, they're really interesting, and we make some just like question observation by using an statistics. We said it as angket. What's in English? Questionnaire. Yes, sorry, questionnaire. And then it's really best result for the happiness because just like visual impaired person, people think that they can use the mobile phone, but the person with the lower vision, they still can use the mobile phone for their self-learning for the braille material. So they're really happy by using this system.
All right. So it's based on the survey. Yes.
Yes.
Direct survey to the participants about this. Because I was thinking that your orange technology is related to what we call the brain-computer interface. There is still some relationship with the brain-computer interface, right? So in the future, I think that happiness stuff, the affective stuff from the affective experience from the users should be detected automatically without asking any questions. For example, using the brain sensors or any kind of sensors that could really identify such kind of experiences from the users.
Yes, thank you.
Okay, right, ladies and gentlemen, I think no one else is asking, just me asking. This is really interesting, Dr. Rani, to be honest. And thank you very much for your talk. And I really appreciate that all of the keynote speakers has spent their time to deliver the presentation in a good way. And what a great session we just had. This is the final session for the first three keynote speakers for all of you. Soon we are going to the parallel session. Rafi and Grace will explain to you the parallel session. And thanks to you. Thanks for the attention. Such a privilege to listen to all of the keynote speakers. So I return the session back to Rafi and Grace. Thank you very much. See you soon.
Thank you for the keynote speaker who were Batik today. Coincidentally, today is National Batik Day.
Ladies and gentlemen, finally the third keynote speaker session is over. But we will have the fourth keynote speaker session with Professor Martin Abner after the parallel session.
Now we would like to give further information about the parallel session. You can see the link for each parallel session in the chat feature.
We will start the first parallel session at 10 to 11 until 10 past 12 local time or GMT +7. Then we will have break and lunch for 15 minutes. We would like to ask all the participants not to leave the room during break and lunch.
Right after the break, we will start the second parallel session at 13 until 15. After the second parallel session, we will the fourth keynote speaker session and 5 past 15 until 10 to 16.
Now we would like to invite all the participants to join the parallel session room. If you have any difficulty or need further information, you can send your question using the chat feature.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Good afternoon, ladies and gentlemen. The parallel session has ended, and we hope you can learn a lot from it.
Welcome back to the fourth keynote speaker session of ICEEIE 2021. Without further ado, we would like to invite the moderator. Please welcome Haris Ar-Rasyid, PhD.
All right. Thank you, Rafi and Grace. Here we go again, ladies and gentlemen. Welcome to our final keynote speaker, Professor Martin Ebner, PhD. A little bit about him. He is currently head of Department Educational Technology at Graz University of Technology, and therefore responsible for all university-wide e-learning activities. He holds an adjunct professor on media informatics, which the research area is educational technology, and works also at the Institute for Interactive Systems and Data Science as senior researcher. His research focuses strongly on seamless learning, learning analytics, open educational resources, maker education, and computer science for children. Professor Martin has given a number of lectures in this area, as well as workshops and keynotes at international conferences. So allow me to invite Professor Martin Ebner, PhD. The stage is yours.
Yes, thank you very much. I hope you have already. Yes, thank you very much for the nice introduction. A very warm welcome from Graz. It's in Austria, and I'm happy to be here and give you some insights about open online courses. I just begin to share my slides. Beforehand, I would like to post you the link of the slides already in the chat, so you can also follow it online. That's the slides. And I give my screen free. So hopefully you see my screen. Yeah. So I would like to talk about IMON and our experiences, and finally I'll also give some hints about if you would like to do your own online course, what must be done, for example. First of all, there is another feedback channel. That means if you type this URL, you can give me to any time any feedback to my slides. I would be very happy to read it afterwards. So if there are any comments, feel free to just address to the slides. The first question is, what is a MOOC? Just a short introduction. I guess you are very familiar with this worldwide movement beginning in 2012. It's nearly up to 10 years now. And it's just an abbreviation of massive open online courses. And the interesting part is each word. To say massive means we are doing online courses for many people. That means at least thousands of people. We have MOOCs in Stanford and in the UK or in the USA with more than 100,000 people in there. So that is much huger than that we have normally at our institutions, at our universities, where you have classes up to, I don't know, 500, 600. Online, you have thousands of people. That's a very huge difference, of course. The second one is it's open. open in many directions. So for sure open in the sense of free access. So that means that you can just register, you can make this course for free. There are no costs on the course. And at our platform, for example, at Graz University of Technology, we are also meaning with that open education resources. So you can take these resources inside of the course, each video, each PDF, each quiz, it doesn't matter, and put it in your own lecture. And that means that you can multiply your course, for example. So that's a really open education resources. And the second O is, of course, for online. So these courses are completely online. There are no presence or face-to-face education, and it's a course. The course means it's a structure. That means that you have different kind of lectures, or you have divided it, you have self-assessments and something like that. You had a start date and end date, and you don't have just a collection of learning materials. That's the screenshot. It's a screenshot of our MOOC platform, for example. It's called imoocs.at for Austria. There you'll find currently about 80, 90 online courses, mainly in German language, but maybe that's also interesting for you as a university, and of course also in English language. And sometimes we have also a translation to different kind of languages. But it's also a very interesting part. So you can also begin to translate courses to different kind of languages. So they have no barriers of language anymore, for example. So you can make just subtitles to the videos, and then you can translate it to any language you would like to have. And that's also a very beneficial way to deal with online courses. The next thing is, for example, you see a screenshot of one particular course. That's the course of Basics of Probability Theory. That's one of the courses of our university, where we have a very international audience. That means we have there people from Finland, people from China, from the USA, and they are doing this MOOC, for example, and it's always the same structure. On the left side, for example, you see the units. The units are divided by the teacher, mainly weekly, but can be also a different kind of time period. You see the course playlist. That means that all videos are also done at YouTube, for example. You have a discussion forum where the people can exchange and communicate. And you have, as teacher, the possibility for a kind of announcements. And the main window, of course, is the content. The content means that you have some hints. You have at least one video per unit. Sometimes you have more. I know courses, they have up to 10 videos per unit. And you have, in the end, a kind of self-assessment. Self-assessment means that the student, as self-regulated learner, can do it to control himself, that have he or she learned everything she should know about this unit, for example. And if you are doing all the self-assessments, in the final end, you get a certificate of the course. That's also automated, of course, and then you can say, okay, I have done this course for my own, and that is used in different kind of lectures or something like that. So the first question, the answer, what is a MOOC? I would say it's can simply describe as an open online course, open in the sense of no costs in the, or even that open license, based mainly on videos, of course. And those videos are no recordings. Those videos are video productions. That means we are really doing learning videos, teaching videos, so especially for such a course. The next thing is, what did we know about MOOC? So we have a very long experience now on these open online courses, and what many people are asking me, when should I do a MOOC, or which kind of benefit do you have, and something like that. And the first thing is, when you're asking me why should I do an online course, I answer, do you like to have a broad audience, or do you have knowledge, for example, who is should go to a broad audience. That's mainly the main difference, because if we are just making classes as our university, we are teaching just normal stuff. But of course, we are doing, for example, research at our university. We have new research, and then we have to think about how we can transfer this new knowledge very, very fast to a broad audience. That means also, how can we bring research very fast to a very broad audience worldwide, or to a special target group or something like that. And if you are thinking about something like that, that you say, okay, I have a very good research results, I have a very good research at my university, and I need to go broad, I need to go broad worldwide with them, then just do a MOOC. It's maybe the simplest form and the best form, to get very broad audience and to discuss with other researchers and something like that. And it's one of our main goals or main aims currently, how we are dealing with that. The second thing is, maybe you have also recognized in the very first beginning of those online courses, we have over the mythos of dropouts. So they tells us, this kind of MOOCs have a very huge dropout, and it doesn't work, as many learners are not finishing, something like that. And that's not really true, because as I show you just from 2014, first diagram. On the left side, you see, for example, the red bar. That is the people who are just registered to the course. It's the main part, of course. And the interesting thing is that the green part are the active students. And active students means the students are coming at least really to the course. They are doing more than just registering. And that's the people who are, for example, just going into this course and doing something, and they're active. And you see, from these people, the violet ones are finishing. And that's the interesting thing. And then you see that you have success rates from up to 50%. That means 50% of the active people are really doing the final certificate, and that's a rather high rate. The next thing is MOOCs are have a very high activity. That means people are learning more or less to any time, at any place, and that's very active, because every of the learner can just choose the time when he's going to the course, when he's learning. But this means that because there are so many people there, they are active about the whole week, every time. And I give you some diagrams on that. For example, you see the activity in the discussion forums. Normally, when a new unit is starting, the activity is always the highest, because you have a new content, for example. And but you see that's very, very high. You have more than 20,000 reads just in a discussion forum or something like that. So you need very high numbers where people are interacting, and of course you can exchange with people from all of the world. This one is also very interesting, because it's very typical for an online course. Typical means that the quiz in the first week, in the first unit, is always the one who is done the most, of course. And then you have a decreasing curve, and up to the unit 4, 5, then it's going rather stable. That means people who are going till the unit 5, you can more or less say they will finish this course, and that's always the same. That's you can do more or less for all the courses. You have a decreasing line to the unit of 4, and then it's rather stable. That's the activity. So you see, for example, when are people reading, for example, in a discussion forum at our platform, and you see when Europe is sleeping, normally at the midnight up to 6 o'clock in the morning, and then it rises very dramatically. That means you cannot learn. So learning is also happening in the evening, is happening till midnight, is happening in the morning. So that is, we have no typical a part where you can say there is at midnight, or there is this, at 2 p.m. or something like that. Then people are in the platforms, and they are always in the platform. And then I have also a part of gamification. So we tried out some experiments and research on how we can improve the engagement of students and learners towards gamification. And we built a kind of battery you see in the you see here in the picture, and that means you get an engagement score. For example, what you have done in the last week. Our idea was that we would like to visualize students, how they are in the course, how they are in relation to the other colleagues, for example, in this course. And the interesting part is, also, if we did exactly this one, then people, you see that the quiz in the unit 2 has more participants than the quiz in the week 1. And this is related strongly to the gamification part, because that means people saw, oh, I'm not so engaged as maybe I should be engaged. And then they begin to do more. And that was the interesting thing. So with this just little small battery, we motivated them more to engage more in the course, for example. And we show that gamification also works if you really directly address the motivation of the students. So what we know about MOOCs, so I have also a final sentence here, means learning happens always at any time on these platforms, but perhaps not as structured as we expected, for example. So it's not easy to just recommend something, because we see that learning happens anytime. So there is no hot zone or something like that. Then also we have also thought about, we are gathering a lot of data, and of course also this data is interesting to visualize. So can we learn something from the data we are gathering? And we are building learning analytics dashboards since the beginning of the platform. And how it works, it's very easy. So we have this platform on part 1, and there is the data of the students, of course, also of teachers. Then we are just taking this kind of data, we are collecting it from log files, we are from activities, for example, or if you get badges, certificates, or whatever. And then we are trying this different kind of algorithm, a kind of visualization. So what would be interesting to visualize, and doing the dashboard, for example. And our idea is that the lecturers get then feedback, more or less, and automatically feedback how the course is performing. And that's also, you see the publication in on the button, where you can find, of course, more detail. I have just a screenshot with me. This is for example, the quick overview. The quick overview means, for example, you need how many people are enrolled in the course, how many are graduates already, how get certificates, how many feedbacks. So you see more than 6,000 badges are just given at this course, for example. And you see, of course, are the participants already finished? Did we have non-active participants, for example? Non-active means last 2 or 3 weeks that was never seen in the course. And how many active have we currently? And you see this kind of course is, of course, a course that's more or less over, and there are just some few active. And you see, of course, what are the people doing there? Yeah, and it's not amazing that, of course, more or less half of the people are just watching the videos. They are doing discussion forums, and the rest is, of course, they are going to documents, and they're doing, for example, self-assessments. Yeah, so that means learning analytics helps us to understand how we can improve our teaching. So we are doing it currently more for our teachers to see, okay, is my course different to the other courses, for example? Are there any problems there? Are people maybe have problems in just which quiz, for example, is a video watched more or not, or something like that? And so you can improve, of course, your teaching material, your learning content, and that the course is performing better in the future, of course. The next thing is the didactical approach. So if you are going to use those online courses, then you have also to think, how do you use this kind of course? Yeah? So we have done more than 200 courses now, and there are more or less different kind of didactical approaches. And what we've done, we just looked at any course, and we make a kind of research and just interviews with the teachers and ask them, how did you use your online course in your lecture? And the result was that we have 7 different kind of principles found. Yeah, so the idea was that we found 7 categories how these online courses are used, and I will show you later on. And the precondition of that is very important is that our courses, of course, are open educational resources. So you just can also go there and say, I can remix it. I can just take a video from another course, for example, and put it in my online course and something like that. And that is a kind of precondition that this kind of categories works. To explain also the graphs you see following on is that we have the start date of a course, the end date. We have also face-to-face sequences, yeah? And we have, of course, the final assessment. That means the students are really getting credits in the end. And the first type we found, it's the classical one. We called it the conventional MOOC. Now, that means that is exactly that, what you are thinking this MOOC works. You have an online course, for example. You go to your students, tell them, just take this course, make it online, and if you are finished, come to the university and you make an assignment. And when you have done the assignment and it's okay, then you get the credits. That's the typical way, or the first way, of course, how MOOCs are used. But it's not the onlyest one. The second one is, we called it the pre-MOOC. This scenario is very interesting, especially for laboratories. So we have one teacher who just told us that he have always problem that students are coming to the laboratory and you have to explain again and again all the instruments, how the research is working, how the experiment is working, and so on. And his idea was that he's making a MOOC where he explained that. So he explaining in the MOOC what do you need for the experiment, how does it work, what have you do. And then he told the students, you have to make this MOOC before you are coming to the laboratory, show me the certificate that you have done, for example, and you can go inside the laboratory. And that was very successful for him, because he said he is now can much more work with the students in the experiments. They understand it better because they have also the time to watch a video again and again concerning the explanation of those experiments. No, this we called it, it's a pre-MOOC. It's a MOOC before the face-to-face education is happening. The second one is the blended MOOC. The blended MOOC is something like very similar if you're thinking on blended learning, for example. So some teachers has the idea to say hello to the students, to explain what is the lecture about. Then that's the first lesson in the face-to-face education. Then they can go home. There is the online course, the MOOC, for example, Unit 1 to Unit 3. Then you come back, ask questions, we make some exercises, we are discussing about that. Then you are going online, of course, make Unit 4 to 8. And then we have the final face-to-face education. So we call that the blended MOOC. And that's also very interesting. So you have more or less in between the MOOC, several face-to-face learning events at the university. Type 4 is a special form of a blended MOOC. It's called the in-between MOOC. The in-between MOOC is often used in workshops. So that means also in adult education. That means we have a kind of workshop. I say my hello and I give an introduction to my topic. Then I go, students are going home for 2 or 3 weeks. They are doing the MOOC and then they come in the final face-to-face education. And that's typically how we use it, for example, in adult education, and you get a certificate afterwards. Yeah, it's the in-between MOOC, in between 2 face-to-face events. A very interesting part is the inverse blended MOOC. The inverse blended MOOC is because we learned that in the case of conventional MOOC, learning is also a social means that you need social learning, for example, you need a discussion, you need other people. And the problem is, of course, if you're doing a MOOC and everyone of the world can do that you don't have really persons where you can discuss, you need the other learners. And then we have the idea that for example, that we organize local learning meetings or a face-to-face meeting, local. That means maybe one in Austria, one in Germany, one in the USA. And there are people are going face-to-face, for example, once a week. And then they are discussing the learning content. What did I learn in the MOOC? And I would just learn and I would like to know what other people are thinking. And if maybe I have some questions or something like that. And that means we have a MOOC and we have in parallel face-to-face meetings anywhere Yeah, and in any setting, that means I know people who are just taking a coffee together, or the people who are going to university for such a learning group, or people who are just meeting in a private room for a learning group. And that was very interesting. The interesting part is that we as lecturers try to motivate them that they are doing that they are finding them. And that's we are calling inverse blended MOOC, because we are bringing an online course back to the face-to-face education in a little bit. And that was the idea of inverse blended. The type 6 is the flipped MOOC. Maybe you're aware of the flipped classroom model. You know, flipped classroom means that students have to go home and study the real content, who is more the fixed one. They're coming back to university and we are exercising them. We are discussing about this content. And of course, you can use a MOOC that. So that means every week the students have to make one unit. They are coming at the university. We are discussing the content. We are making the exercises on that and something like that. And that's very, very interesting for lectures with math content, of course, because exercise is the most important part. And of course, your input is just a video. Yeah, and finally, we called it a lecture MOOC because it's often happening. A lecture MOOC means we have an online course and we have a parallel learning management system, because also many parts of the course itself or the lecture itself cannot go public. So for example, you have final grades, you have assignments and something like that. And that is done in the learning management system. And the MOOC is running for the public, because the content, this doesn't matter, is also interesting for the public, because the public does not need to make any assignment. And that's we calling the lecture MOOC. And that are these 7 types of different kind of didactical approaches. That means if you have a MOOC, so you're doing something with that. And we learned that's very interesting, because people are just dealing very flexible with this kind of online content. Yeah, if you're interested also to take a closer look, you have a URL in the bottom of this slide, and we have done it on a folder. For example, we called it 7 teaching and learning scenarios with MOOCs, and this is there you can just study what we studied about our work. The next one is how can we do our own MOOC, because if you are interested to do also online courses, we have learned that we have to give something to the teachers. It's it's a huge project. So it's not just lecturing, making some slide. It's really a project. Normally we need just 1 year to produce a MOOC, for example, and therefore we make this MOOC maker canvas. That is for the teachers. Yeah, that means that's the first step. If you would like to make a MOOC, so we have this canvas, and you have to think about it. Which kind of idea, which kind of MOOC project? What is your objectives? What are your partners? What is your license? And something. Which kind of quiz? Which kind of assignment do you like to make? And this is the first thing you have to do. And that our teachers became this kind of canvas. We just fill them out with them, and then we are talking about, okay, what must be the next steps? For example, mostly we are doing the video production. And if you're more or less ready, in parallel, we are also educate certified course creator. But it means how do you bring all this content completely in this MOOC? And then we have, in German, we have 10 steps. And in these 10 steps, for example, you have to, you have to make a user at the platform. You have to think about the badges and something like that. So there's also a huge thing. So what I would like to say to you is a MOOC is something, it is a huge project. So you need time for that. And it needs also very good planning. So making a MOOC follows a very good organization. That is one of the most important points. Finally, my last question is, must MOOCs be open? Of course, you can also do just an online course for a restricted kind of people. And there I have 2 slides. The first is, if this content is really open licensed, is a so-called open education resources, the exchange between other institutions, that means not only university, that means also industry, for example, and the usage of this external organization becomes rather simple and legal. That means open educational resources works as a motor for the exchange between the industry and, we all need projects, research projects, and we get in touch with them. We say, take a look what we are researching about. Is this interesting for you? And something like that. And the second thing is these OER MOOCs facilitate access to education, of course, in an innovative way, and allow new forms of teaching and learning, as I showed you with this 7 kind of categories. So must be open is simply a yes. So we learned it doesn't matter to restrict it. It's much better to open this kind of courses. It's learning and teaching, and people know what we are doing at our university, for example. So, and this is my really last slide. That's more or less the last sentence. We see that these MOOCs, for example, are not a trend or not a hype. It's just a consistent and logical further development of online teaching, more or less, and help to make educational content accessible. That is also very important. So I would like to thank you for your attention, for the possibility to talk to you. I just stop my slides. Thank you very much.
Thank you very much, Professor Martin Ebner, for such an enlightening presentation. We all really enjoyed, well informed, as well as inspired from your presentation. I think for me and all of us are now understand how MOOC is the potential strategy to learn any subjects during this pandemic era. Everybody should agree with that, considering that the technological advancement is also perfectly fit for that. All right, ladies and gentlemen, we are now come to the question and answer session. You may use the Zoom's raise hand or just raise your hand in front of the camera. And then don't forget, if you are in the spotlight for the question session, mention your name and country. Please do so immediately. We have probably two or three questions. Oh, there's one. Thank you. Professor Yuni Rahmawati, please. You can unmute your microphone.
Okay. Okay, thank you, Mr. Harris. As moderator, thank you, Mr. Professor Martin Ebner, that have great material for us, and I will ask some question, Mr. Ebner. This is about how we can increase about the technical skill when we have MOOC, in which type that we can choose the best for the to increase the technical skill. This is about the practice or something like that. Maybe how to increase to maybe employability skill too. In which one with menus and extra. Maybe you can explain to me which one the best from all the types of MOOC that you explained today. Thank you very much, Mr.
Yeah, we have, for example, done MOOCs about digital competencies, or digital skills, for example, digital literacy, and we have done this also for school children and study beginners. And what we have done is that we take the European framework on that, on the digital skill frameworks, and we make for each part, and that's I think 26 kind of digital skills, an own video, an example. For the target group, that's very important. That's we have to think beforehand about is there children, are there adults, or something like that, and then we put links there, and we put additionally also a lecture on that, and that's for our students who are really coming at the university, and it's a free lecture. That means that it's not obligatory. That means we are telling them that we are offering them that. If they are feeling they are not so competent in the kind of digital literacy, then this kind of online course is used. And we are also doing this for computer science. We call this computer science fit course and math. That's so-called bridge courses. And these bridge courses done before the university is starting. So that's they began, so they come to register at our university. Then we give them a folder and we say we have 2 courses for you, for example, computer science and math. And if you are feeling you are not so good in that, or you would like to know what we are expecting, what is your competence at the start of the university, just take a look to this course. And currently about 1/3 of our university student beginners. That means that we have about 1,500 each year, so about 500 are taking these courses. And that is only the idea to make them comfortable to going to start, of course, yeah.
All right, thank you very much, Professor Yuni Rahmawati, for the question as well as the response from Professor Martin Ebner. I believe that
okay, thank you very much.
You're welcome. I believe that implementing MOOC requires not just the technological readiness, but also the people who runs the MOOC as well, right? How to prepare the material. It's not the ordinary and conventional material. You also need to prepare more interactive materials, more understandable material, because you have to present it online, where there are no physical interaction between you and the learner. So one more question. There is Mr. Utomo Pujanto, please.
Okay. Thank you, Mr. Haris. Good afternoon, Professor. I have 2 questions actually, but it's a short one. First, can we build some sort of suggestions based on the learning analytic platforms to suggest to have to bring recommendation for the lecturer, which strategies that that we should that he can do between the 7 strategies for the lecturer. So some sort of automatic suggestions based on the previous history of lecturing based on MOOCs. And the second question is about gamification analytics. Is there any research in the iMOOCs that has been conducted on the gamification analytics? Thank you very much, Professor.
Yes, thank you for the question. Just to the question before, I give just a publication to the bridging courses in the chat. Maybe you're interested in that. Yes, of course. So we tried very many different things because of course we have a lot of data, and we also thought about recommendations or something like that. The main thing is that's not so easy because we are talking about learning and teaching, and we simply often did not know why a student is successful because we just know his data and his activity on the platform. And currently we are a little bit researching about assignments, where the idea is, did we see that the people maybe who are going very fast to the self-assessments or something like that are more successful than people who are just doing it not so fast or something like that. And the only thing we are currently have a little bit found, so there's a very weak correlation, is that a student who is doing the first self-assessment, it doesn't matter in which kind of unit, successful, has a more likely success rate in ending the course, for example, that we just know. So we have a lot of data. The main problem is that we just know a kind of click rate, yeah, and you know from clicking around, you don't know is the user now learning or is he just looking in another tab because it's just open or something like that. So, and we another maybe interesting thing is about the learning with videos. So we see, for example, we are using this H5P module for interactive videos, and we see that interactive videos are much more better used than non-interactive videos, of course. And we know that this interaction is a very really hot spot for the students. So that if there is an interaction in a video, they are going really there. And it's very important to know as teacher, because you have to know that your interaction is a very, very hot topic for the students and something like that. So we are building recommendation for teachers, but it's in a very general way. So it's not, we cannot exactly say this is really successful, for example. So what we can do is we give you some hints that we see that in this courses, for example, this kind of usage of the video is performing a little bit better. But of course, it can also be related on the target group, on the topic itself or something like that. The second question, the gamification, yeah, we are really sometimes working a little bit on that because it's a very hard way. Gamification, we are using badges since the beginning of the platform that's running. As there are really people who are collecting badges, for example. For them, it's very important to get these badges. And so we have around 10-20% of the people who are collecting this kind of badges. The rest, that's not interesting to them, for example. But it means that gamification also deals with a kind of target group. And that means which kind of people do you address with this kind of gamification? And as I showed in the talk about the battery, that was a success thing, but it's a very, very small part. And we have also always to deal with the motivation of the students, and that's the hard thing. I will also look also because there was also a publication about the battery. If I find them, then I will post it in the chat.
Okay. Thank you very much, Pak Utomo, for the question and the replies from Professor Martin Ebner. For your information, Professor Martin, Pak Utomo has a research field in learning analytics as well. So probably Pak Utomo can collaborate, doing collaborative research with you in the future, or starting from now, maybe. That would be interesting. Right. One more question, please. Anyone? Oh, Pak Haji, please, Pak Haji. Yes, where is Professor Haji?
Okay, thank you for the time, Mr. Moderator. Professor Ebner, it is nice to see you here first. This is my first time to see you directly instead of your papers. Okay, I have a question. It is about, actually I have a, it is not my question. It is a question to me that I cannot answer. Okay, so it is about when we create e-learning and develop the e-learning or MOOC and something else, but it is about the what's that, the needs and habit, for example, for this pandemic era. But the problem is about the evaluation. Yeah, the evaluation of the e-learning itself. Do you have any idea, or I need your thought about the evaluation of the e-learning, how we can know how efficient the e-learning that we develop or we conduct? Thanks, Professor.
Yeah, this is one of the hardest questions. Also, what we would like to hear is how we can say that the learning is going better with technology or not. And the exact answer is that learning is independent of technologies. It was always the same. It was in 2000 the same, in 2010, and always. So that means that we per se cannot improve learning because we are just using technology. Because learning is always on your individuum, is learning on your side. And the most two things what you can do with technology is to increase the motivation of the students, because maybe you are using it in a more appropriate way, in a more innovative way, or something like that. And you can improve the didactics. That means you can maybe lecture in a different way. And these are two main factors how you can improve the learning in the end, yeah, but it's not directly measurable. So otherwise, you would say if you're not using technology currently, then you are an old university, so nobody will come to you because everyone say, oh, they have no technology there. I cannot just read from the blackboard or something like that. So you have to use this technology, and then you have to think about how we can use it in a maybe new way. Think about collaboration, for example. Also, only technology allows collaboration if you're thinking on Google Docs or something like that. That is not possible on the paper. And that's the new things, the new motivation, the new innovative things. And that is how we can improve our teaching and learning itself. Yeah? But you cannot say, okay, because we are just using iPads, then the people we are going have better results. That's not possible, yeah? Because I can show some results where it's completely the other way around. And that's the main thing, motivation and didactics. And that's hard to evaluate. Yeah, also to say, okay, people are more motivated, they can then they're not so motivated a year ago or something like that. And that's the hard thing. So you can just always ask, is this a more didactical way? Is it different? Yeah, and how people are reacting on that.
Okay, thanks for the motivation and the didactic.
Yeah, that's the two parts. Yeah. They are very important parts for successful learning. Yeah. That's but it's very hard to make experiments on that, and then you see that because you can do that in the laboratory, but normally we are working in the field. In the field, there are different kind of parameters, different kind of people, different kind of students, so it's very hard to get exact results.
Yep. Thank you very much.
Great. Thanks for the enlightenment, Professor. For your information as well, you, Professor Martin Abner, you have introduced the iMOOCs in our campus in Universitas Negeri Malang. We have UMOOCs. We've built that one, but as we all know that we've built from scratch. We have to build from zero, from ground, and the effort we have to dedicate is humongous, and we have to do everything a lot, and we have to. I don't say that we have to compete with the Moodle stuff, LMS, but we're trying to create a breakthrough on learning in this pandemic era. Right. Thank you very much, Professor Martin Ebner, for your inspiring information, inspiring presentation. We just had a great session with you. Thank you, everyone, for your participations. Most of all, thank you to Professor Martin Ebner and all the keynote speakers for your presentation and enlightenments. Thank you very much. We hope that the future will come for the better and better life. Amen. Thanks. Thank you again. See you soon. And the session is back to you, Rafi and Grace.
Thank you, Professor Martin Ebner.
Before we close this event, we would like to thank the engineering faculty of Universitas Negeri Malang for organizing and hosting this event.
We would like to thank the chairman of ICEEIE 2021,
the representative of IEEE Indonesia,
the rector of Universitas Negeri Malang,
all the board leaders of Universitas Negeri Malang,
the keynote speaker of ICEEIE 2021,
the organizing committee, and all the participants of today's conference. We would also like to thank our sponsor, Antik Batik Malang, as our wardrobe.
We highly appreciate your participation on the 7th ICEEIE 2021.
We hope you get a lot of knowledge from today's conference.
We wish to have you again on 8th ICEEIE 2023.
Thank you and see you.
Gimana Pak Ilham untuk kegiatan ini hari ini?
Alhamdulillah lancar.
Lancar. Harapannya gimana, Pak?
Ya, semoga lancar ya sampai akhir kegiatan. Kemudian setelah itu kita akan lanjut ke proses sampai ke ICEEIE. Semoga lancar juga.
Ya, semoga
terpublish semua.
Amin, amin. Makasih Pak Ilham. Alhamdulillah 1 bulan habis.
Ketiganya Desember.
Oh iya, mantap. Oke, gimana acara buat hari ini, Pak?
Lumayan lancar sih untungnya.
Ya, harapannya nanti?
Harapannya ya bisa lancar terus sampai selesai.
Sampai selesai ya. Oke, makasih Pak.
Terima kasih.
Penanggung jawab ini.
Ya, ini Ibu Juragan baru datang. Gimana Ibu Juragan? Gimana? Kita lihat dulu nih. Lampu-lampunya mantap. Nah, ini bagian setting panggung, teman-teman. Setting panggung. Apa yang dilakukan, Mas?
Panggung Pak saya.
Ya,
Bagian stage.
Oh, manajemen stage-nya ya.
Iya.
Aplikasinya pakai apa nih?
Panggungnya.
Oke, ini preview panggung, teman-teman. Dengan Mas siapa?
Raden.
Oke, Mas Raden dari Kadif IT ya?
Iya.
Betul. Sip, mantap. Serius. Aku jaluk langsung bisa dong. Itu langsung di play nomor ini. Oke. Video ya. Video. Bagian apa, Mbak?
Redeemer. Redeemer yang ganti nama.
Oh. Nah.
MC-nya coba pas dulu.
Bagian apa, Mas? Bagian apa?
Bagian admitter.
Oh, admitter. Mantap. Udah di admin semua ya?
Sampun. Bisa.
Mantap. Peserta juga banyak. Ruang produksi, teman-teman. Si acara sehat.
Seksi repot.
Master of Jaringan.
Seksi repot. Seksi repot dan merepotkan orang lain.
Tanggung jawab. Kalau online itu kan nggak repot. Apa yang ngomong? Dari rumah kan bisa.
Oh iya, betul. Lebih enak, lebih keren.
Gimana persiapannya ini, Mas?
Ya, lumayan menguras tenaga dan waktu.
Memang lebih enak kalau dia khawatir. Ya kan? Begitu ya.
Yes,
menyiapkan
sukses.
Tempat ini.
Yang paling enak di hotel.
Iya. Ini Mbak MC-nya ngantuk tidur semalaman nggak aneh.
Bahaya.
Oke, kita menuju ke streaming YouTube.
Ya,
YouTube-nya apa ini, Mas?
YouTube-nya Elektro, Pak.
Elektro ya? Viewernya banyak ya?
Sudah menurun. Wajib jalan ya Web. Wajib pakai data. Oh nggak keluar ya. Keluarga. Coba beri kostumnya juga.
Berjuang. Gimana Mas Elsa?
Alhamdulillah lancar.
Persiapannya berapa hari?
Persiapannya hampir 2 minggu.
2 minggu ya? Wih, mantap ya.
Sukses untuk ICEEIE 2020.
Oke. Gimana Bu?
Sukses
Tanggapannya?
selalu aman, masih aman terkendali dan semoga aman sampai akhir. Semangat.
Amin, mantap. Gimana Bos?
Sudah sehat Bos.
Alhamdulillah. Hexagon gimana?
Oh, hexagon.
Apa?
Hexabot.
Hexagon.
Ya, hexacakramala ya. Oke?
Iya.
Siap. Tanggal berapa Bos?
Tanggal berapa?
Besok Bos.
Besok.
Minggu besok ini Bos.
Oh, udah disiapkan di sana.
Ya, bentar lagi propos GKP lagi Bos.
Tapi udah anak-anak sudah di sana?
Belum.
Belum.
Masih dikontrak.
Masih istirahat lah ya.
Iya.
Apa yang terjadi besok terjadilah.
Iya.
Oke.
Terima kasih Bos
buat acaranya. Halo. Ini ada Pak Hamdan dan Pak Afnan. Ini ruangan apa Pak?
Ruangan moderator untuk 12 paralel room.
Oke.
Bisa kita lihat ini mahasiswa yang bertugas untuk operator masing-masing 12 paralel room.
Ini untuk PJ-nya masing-masing room ya? Luar biasa. Udah ready?
Ready Pak.
Room berapa?
Room 6 Pak.
Room
sama Pak Muladi.
Halo Mbak. Room berapa?
5.
Room 5. Oh, dengan siapa? Masih jauh. Beliaunya nggak ada di sini. Mantap. Gimana Pak Amdan?
Alhamdulillah mantap.
Hari ini dengan saya dong.
Ya, saya dengan Pak Wahyu.
Presentasi?
Ya, nanti saya sama Pak Wahyu.
Oke.
So the orange is
Halo. Room berapa?
Room 1 sama 10.
Mantap. Halo. Sudah siap? Bantu untuk kelancaran acara. Room berapa ini?
Room 2 sama 10.
2?
Iya.
Wah, mantap. Room berapa?
Room 4 sama 12. Roomnya Pak Wahyu.
Saya nanti.
Room 4 kan.
Oh iya ya. Terus kalau misalkan nggak hadir, nanti yang muter video?
Oh, yang muter video bisa presenter ataupun saya juga bisa.
Oh iya. Nanti minta tolong ya.
Oh iya.
Kalau misalkan saya kesulitan.
Iya.
Lancar nih.
Lancar Mas.
Nggak ada project kan?
Ada Pak.
Oh ada ya. Harus selalu ada ya.
Harus selalu ada.
Harus bergerak. Room berapa?
Room 7 Pak.
Dengan siapa?
Dengan Budian.
Oke, sampai nanti sore ya. Mantap Budian. Mantap. Gimana Pak Afnan harapannya buat hari ini?
Harapannya kami semua doakan supaya berjalan lancar, tidak ada kendala teknis satu apapun, dan kita memberikan manfaat kepada orang-orang yang hadir, baik kita maupun yang telah menghadiri conference kami. See you in the next conference.
Oke, mantap. Ini calon ketuanya.
Calon ketuanya itu Pak
ICEEIE 2023. Pak Mahfud jelas nggak bisa, Pak.
Oh iya,
jelas nggak bisa. Jadi Pak Arkan
ya.
Oke, selamat.
Selamat berkreasi. Kita membuat sejarah hari ini untuk ditingkatkan lagi di periode berikutnya.
Oke, makasih. Mari kita lanjut teman-teman ke ruang berikutnya. Oke, sampai ketemu Pak Amdan. Udah lama kita nggak ngobrol-ngobrol ya. Ya. Ini kita ke ruang koordinator lab teman-teman. Tapi nggak ada orangnya. Kita pindah aja. Associate Profesor Harits. Beliau yang memandu jalannya acara hari ini, teman-teman. Semoga lancar, Pak. Kopi lagi. Halo, Pak. Gimana Bu Moderator persiapannya hari ini?
Sedang menyiapkan mau ngomong apa?
Ya mantap. Konsumsi. Oh iya betul. Gimana Pak Fauzi?
Alhamdulillah lancar.
Lancar. Fasilitas sudah lengkap semua ya?
Alhamdulillah.
Sarpra sudah oke? Tinggal pelaksanaan aja ya?
Sudah kita monitoring, semua sudah siap.
Oke. Krunya ada berapa nih? Tendik yang terlibat?
Yang terlibat sekitar 7 orang insya Allah.
7 orang ya?
Ya dari elektro.
Oke. Terima kasih Pak bantuannya. Kerja kerasnya. Ini videografernya kita teman-teman. Ada gimana Pak hari ini?
Mantap, beres, selesai.
Ini Sam Uget yang kemarin juga telah ngambil video dari awal rektor.
Sekarang lanjut lagi.
Sekarang lanjut kemana Pak?
Ke ruangan.
Oke. Monggo silahkan Pak. Tim persuratan teman-teman. Nah, di sini ada ibu-ibu, mantap. Lancar ya Pak? Lancar. Oke, masuk.
And the aim is the visual impaired able to operate the mobile phone, means using QWERTY phone for their
Halo. Aman bosku.
Aman.
Lancar ya?
Car.
Halo Mbak. Gimana persiapan?
Sudah aman. Habis ini makan lagi ya, tenang.
Alhamdulillah. Makasih kalau disediakan makanan.
Apa?
Kemarin WA saya ngapain Mbak?
WA, oh ikut surat tugas.
Oke. Gimana untuk hari ini harapannya?
Semoga cepat selesai acaranya.
Semoga cepat selesai. Next, 2 minggu lagi kita ada kegiatan juga, seminar nasional juga.
Apa? Nasional tapi kan?
Iya, seminar nasional dong.
Mas.
SNIE. SNIE. Iya, HMC.
Oh kita nggak ikut ya?
Ikut dong semua. Dan nanti mendadak.
Oh no.
Ayo, kayak ulang tahunnya seru. Oke. Ibu, saya tinggal dulu. Oke, dadah.